Hello world, my name is David Malin, and this is CS50's Introduction to Programming with Python. Whereas CS50 itself is an introduction to the intellectual enterprises of computer science and the art of programming, this course is specifically focused on programming in Python itself. At the beginning of the course, we focus on a topic in programming known as functions and variables, mechanisms via which you can write code that solves smaller problems, but you can compose those smaller solutions into solutions to larger problems still. We'll then transition to a look at conditionals, a way in code of expressing yourself logically to maybe do something if some question has an answer of true, or not do something if the answer is false. We'll transition thereafter to introducing you to loops, the ability in code to do something again and again and again some number of times. We'll then transition to something a little more technical known as exceptions. Unfortunately, a lot can go wrong when you're writing code. Some of it your fault, some of it perhaps someone else's fault, but you can write code defensively, so to speak, and actually catch those kinds of exceptions, those errors, and handle them properly so that the users you're writing code for don't actually see the same. Thereafter, we'll take a look at libraries, third-party code written by other people often, or perhaps yourself in the past, that you can use and reuse in your own projects so as to avoid reinventing the wheel again and again. We'll look thereafter at something called unit tests. It turns out you'll actually write code to test your own code, but you won't have to write tests for your tests. Indeed, this is a best practice in industry, writing tests for your code so that, one, you can be sure that your code today is, hopefully, if your tests are correct itself. But moreover, if you or someone else modifies your code tomorrow or down the line, you can rerun those same tests to ensure that those new changes have not broken anything about your own code. We'll then take a look at something called file I/O, I/O for input and output, the ability to not just store information inside of a computer's memory, but rather save it persistently to disk, so to speak, to files and folders. We'll then take a look at another technique known as regular expressions, whereby in Python you can define patterns and you can validate data to make sure the human types something in as you expect. You can use regular expressions to extract data, perhaps from some data set you're trying to analyze. We'll then take a look ultimately at object-oriented programming, a paradigm, a way of writing code whereby you can represent in code real-world entities. And this is in addition to other paradigms of programming that we'll also explore, among them procedural programming, where you write lots of those functions, procedures really, top to bottom to solve problems step by step, and even something known as functional programming as well. And then at the very end of the course, we equip you with all the more tools for your toolkit. And additional building blocks, additional vocabulary via which after this same course you can go off on your own and either take other courses or solve projects of your own using all of these mechanisms. Now this course itself assumes no prior programming background, so you don't have to have written a single line of code in Python or any language yet. But this is also a course that you can take before, during, or even after CS50 itself if you'd like to get all the more versed with Python. Each week, via the course's lectures, we introduce you to any number of concepts that we'll then drill down more deeply into in the form of problem sets each week. That is, programming projects that will enable you to apply some of those lessons learned to problems of your very own. And by the end of the course, you'll have solved so many problems that ideally are representative of problems you'll eventually encounter in the real world. Whether you aspire to solve code in the technical world, or perhaps in the arts, the humanities, the social sciences, the natural sciences, or beyond, you'll have ultimately the vocabulary and the technical skills via which to approach the same. This then is CS50, and this is CS50's Introduction to Programming with Python. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on functions and variables. But odds are many of you, most of you, have never actually programmed before, so let's start by doing just that. Let me go ahead here and open up my computer, and on it a program called Visual Studio Code, or VS Code, which is just a very popular program nowadays for actually writing code. Now, you don't have to write code using this particular tool. In fact, all we need at the end of the day is a so-called text editor, a program for writing text. And heck, if you really want, you could even use something like Google Docs or Microsoft Word. You'd have to save it in the right format. But really, at the end of the day, all you need is a program for writing text, because that's what code is, text. Now, within this particular program, I'm going to have the ability to create one or more files via this top portion of the screen. And I'm going to do so by diving right in and doing this at the bottom of my screen. At the bottom of my screen is a so-called terminal window. And this is a command line interface, or CLI, interface to the underlying computer, be it your Mac or your PC or even some server in the cloud. And what I'm going to do here is literally write code and then the name of the file that I want to code, for instance, hello.py. As we'll soon see, any program that you write in Python generally has a file name that ends in .py to indicate to the computer that it's indeed a program written in Python. Now, you'll see here at the top of my screen, I have a blinking cursor, a line 1, which is where the very first line of my code is going to go, and then just a tab that reminds me of the name of this file, hello.py. And without even knowing much Python, I'm going to write my very first program here as follows. Print, open parenthesis, quote, hello, comma, world, close quote, and close parenthesis. And you'll see that at my keyboard, some of my thoughts were finished for me. I only had to type one parenthesis, and the other one automatically appeared. And that's just a feature that we'll see of tools like this tool here. Now, even if you've never programmed before, odds are you can guess, infer what this simple program is going to do. And it's only one line. Print, open parenthesis, quote, hello, world, close quote, close parenthesis. Indeed, when I run this program, ultimately, it's just going to say hello to the world. And in fact, this is a very famous, perhaps the most canonical program that you can write as your very first program in Python or any other language. And so that's what I've done here. But on my Mac, my PC, even my phone, I'm generally in the habit, like you, of running programs by double-clicking an icon or just tapping on the screen. But I see no such icons here. And in fact, that's because my interface to at least my current Mac or PC or some server in the cloud is, again, only a CLI, command line interface, which even though it might feel like it's a step back from the menus and buttons and icons that you and I take for granted every day, you'll find, we think, that it's ultimately a much more powerful interface and incredibly popular to use among programmers in the real world. So to run this program, I'm going to have to use a command. And I'm going to move my cursor back down to the bottom of the screen here, where previously I already ran one command, the command code, which has the effect of opening VS Code in my computer. And then I passed in the name of the file that I wanted to code up. Now I have a chance to type a second command, and you'll see I see a second $sign. Now, the $sign here doesn't indicate any kind of currency or money. It just is the symbol that's generally used to indicate your prompt, where the command line interface wants you to put those commands. Now, the command I can run here is going to be this. I'm going to run Python of hello.py. Now, why is that? Well, it turns out that when I actually write code in a language like Python, it's, of course, stored in that file, hello.py. But I need to interpret the code top to bottom, left to right, so that the computer knows what to do. Indeed, at the end of the day, even if you don't really know much about computers, you've probably heard that computers only understand zeros and one, the so-called binary system. Well, if that's the case, then something that says print and parenthesis and quote unquote hello world is not surely zeros and ones. We have to somehow translate it into the zeros and ones that the computer understands. Now, fortunately, so long as you've installed such a program in advance, there's a program as well as a language called Python. So Python is not only a language in which we're going to write code, it's also a program, otherwise known as an interpreter, that you install for free on your own Mac or PC or some server in the cloud. And you can then run that program, that interpreter, passing to it as input the name of your file, like mine here, hello.py. And then that program, that interpreter, will handle the process of reading it top to bottom, left to right, and translating it effectively into those zeros and ones that the computer can understand. So let's do just that. Let me go back to VS Code here. I already typed out Python of hello.py, but I didn't yet hit enter. And that's what's now going to kick off this command. And hopefully, if I didn't mess any of this up, I should see my very first program's output to the screen. And voila, hello world. So if you too have typed exactly that same code and have executed exactly that same command, you will have written your very first program, in this case, in Python. Well, now let's take a step back and consider what is it that we actually just did and what is it we're looking here on the screen. Well, first and foremost, in most any programming language, you tend to have access to what are called functions. A function is like an action or a verb that lets you do something in the program. And generally speaking, any language comes with some predetermined set of functions, some very basic actions or verbs that the computer will already know how to do for you, that the language really will know how to do for you, and you, the programmer, the human, can use those functions at will to get the computer to do those things. Now, the program in question here, hello.py, is using one function. And you can perhaps guess what it is. That function is, of course, going to be this function print. And that print function, of course, doesn't print some preordained string of text. That is to say, it prints whatever it is you want it to print. And here, too, do we have another piece of terminology in the world of programming, namely arguments. An argument is an input to a function that somehow influences its behavior. The people who invented Python, of course, didn't necessarily know what it is you and I are going to want to print to the screen. So they designed this print function using these parentheses with the ability to take as input some string of text, be it in English or any other human language, that is what you want this function ultimately to print onto the screen. And what is it that the program's ultimately doing on the screen? Well, it's printing, of course. It's showing us hello world on the screen. And that's generally in programming known as a side effect. It can be visual, it can be audio. In this case, it's something that appears on the screen. And functions, therefore, can indeed have these side effects. One of the things they can do as this verb or action is to display on the screen as a side effect something like those words that we wanted, hello world. So that's my first program. And, I'm feeling pretty good. Everything worked as planned. I didn't make any mistakes. But honestly, when you're learning how to program, and even once you've learned how to program years later, you're going to make mistakes. And those mistakes, of course, refer to a term you might already know, which is that of a bug. A bug is a mistake in a program. And they can take so many forms. And take comfort, perhaps, in knowing that over the coming weeks, you're going to make so many mistakes. You're going to have so many bugs in your code, just like I did, and just as I still do. And those bugs themselves are just mistakes that are problems for you to solve. And over the weeks to come, we're going to give you a lot of tools, both mental and technical, via which you can solve those problems. But just don't get discouraged if when writing your program for the first time, it doesn't even work that first time. It will, with time, with practice, and with experience. So let me deliberately now make a mistake that there was a non-zero chance I might have done accidentally already, but I got lucky. Let me go ahead and just suppose I forgot to include something like the closing parenthesis at the end of this line of code. The code is almost correct. It's like 99% of the way there. But now that I've pointed it out, it's pretty obvious that it's missing that closed parenthesis. But even little, seemingly minor details like that you and I as humans wouldn't really care about. And if you're sending an email or a text message, whatever, it's just a typo. It's not that big a deal. It is going to be a big deal to the computer. A computer is going to take you literally, and if you don't finish your thought in the way the language expects, it's not going to necessarily run at all. So let's do this. I'm going to go ahead here and clear my screen down at the bottom, just so I can start fresh. And I'm going to go ahead and run this version of my program after having made that change by deleting the parenthesis. I'm going to go ahead and type Python again of hello.py. And this time when I hit enter, I'm hoping I'm going to see hello world, but here we have an error on the screen, a so-called syntax error, which refers to my having made a mistake at my keyboard. And this one, fortunately, is pretty straightforward. It indeed says that this open parenthesis was never closed. And so that's probably pretty intuitive now what I need to do. I need, of course, to close it. Unfortunately, sometimes the error messages we'll see in the coming weeks are not going to be nearly that user-friendly. But there, too, again, with experience, with practice, will you get better at debugging such programs. Let me now make sure that I indeed fixed it correctly. Let me go ahead and run now hello.py and hit enter. And voila, we're back in business. Well, let me pause here and see if we have any questions now about Python itself, writing or running even the simplest of these programs.
Could I write code inside a Word or, for example, Microsoft Excel? And what's the barrier to doing that?
A really good question, and allow me to very explicitly say to the entire internet that you should not write code with Microsoft Word. I mention that only because it's a tool via which you can write text, and code is, at the end of the day, just text, but it's not the right tool for the job. We don't need bold-facing, underlining, paragraphs, and the like. We generally want something much simpler than Microsoft Word or Google Docs, and so VS Code is an example of just a more general-purpose text editor. Its purpose in life is to allow you, the human, to edit text. Nowadays, these text editors come with many more features. In fact, you'll notice that even in my code here, even though it's just one line, there's a bit of color to it. The word print for me is appearing in blue. The parentheses are black. And we'll see as we might write more lines of code, more and more of the lines will come to life in various colors. Now, that's just one feature of a text editor. We'll see, too, that it has features like this built-in terminal window. It's going to have a built-in tool for debugging or finding problems with code. And it's just a very popular tool nowadays. But there are many, many others out there. You're welcome to use them for this course and beyond. We just happen to use this one in large part too because you can also use VS Code nowadays for free in the cloud. How about one other question here on programming with Python or Hello World or syntax more generally?
Okay, I was trying to ask if it is not possible to run the code without using the terminal window.
I think I heard, is it not if it's possible to run the program without the terminal window? Are you?
Yes, sir.
OK, you froze for me again, but let me infer what the question is. So in this environment, as I've configured my computer, I can only run these Python programs via the terminal window. Now, that's good for me, the programmer, or the person who's trying to learn how to program, but it's not very good if you want to ship this software and have other people use your actual code. You can absolutely write programs and then allow other people to use not a command line interface, but a graphical user interface, or GUI, GUI. This is just one mechanism, and perhaps I think the best one with which to start writing code, because eventually it's going to give us a lot more control. Allow me to forge ahead here, but please feel free to continue asking questions along the way, if only via the chat. And let's consider now how we might go about improving this program. Let's go about improving this program to make it a little more interactive and not just assume that everyone is going to want to be greeted more generically as hello world. Let's see if I can't get this program to say something like hello David, or hello Jeremiah, or hello Horatio, or whatever the actual user's name is. Well, to do this, I'm going to go back up to hello.py, and I'm going to add another line of code at the very top that simply says, for instance, what's your name, quote unquote, with an extra space at the end. So I'm printing to the user, asking them a question for some input, but now I need another function to actually get input from the user. And perfectly enough, Python comes with a function named input. So here I'm going to go ahead and call a function input, open paren, close paren. And that's going to prompt the user with just a blinking cursor waiting for them to type something in. Now, it turns out if I read the documentation for the input function, it actually takes an argument itself. I don't need to use print separately and then prompt the user for input. So I can actually simplify this code before we even use it. I'm going to go ahead here and take that same string from print, put it as an argument to the input function, and get rid of the print altogether. And in fact, that print would have added a new line anyway. So now I've just got a prompt where the user's cursor is going to end up blinking at the end of the line, asking them, what's your name? In my terminal window, I'm going to run Python of hello.py, enter. OK, we're making progress. It seems that this new function input is indeed prompting me, the human, for input. So I'm going to type in my name, David, and hit enter. Unfortunately, it doesn't really do anything with my name. It just outputs it immediately. All right, well, I could fix this, right? I could go up to line 2, and I could change world to David. And then back in my terminal window here, I can do Python of hello.py, enter. What's your name? David, enter. And there we go. All right, now I'm up and running. Now my program is working as intended. Of course, this isn't really working as intended here. Let me go ahead and try pretending to be my colleague Carter here. Well, Carter's name is this. I'm going to go ahead and hit enter, and I'll see, of course, hello Carter. Well, obviously not, because I've hard-coded, so to speak. I've written literally my name inside of the string. So we need some way now of actually getting back what the user's input is and doing something with it ultimately. And for this, we're going to leverage another feature of programming, specifically a feature of some functions, which is that they can have return values as well. If you think of input as being, again, this action, this verb, you can actually personify it as maybe a person, like a friend of yours that you've asked a question of. And you've asked your friend to go get input from someone else. Go ask that person their name. And if your friend comes back knowing that person's name, well, wouldn't it be nice if they handed that name back to you? That's kind of what we need metaphorically the function to do, is get the user's input and then hand it back to me so that I, the programmer, can do something with it. But if it's going to be handed back to me, I kind of want to put it somewhere so that I can then print it back on the screen. I need to do the equivalent of take out like a piece of paper or a Post-it note, write down on this piece of paper what it is the human has said so that I can then feed it into as input that print function. And to do that, we're going to need one more feature of programming, namely variables. And odds are most everyone's familiar with variables from math class way back when, x and y and z and the like. Well, programming has that same capability, this ability to create a variable, in this case in the computer's memory, not just on a piece of paper, and that variable can store a value, a number, some text, even an image or video or more. A variable is just a container for some variable. A variable is just a container for some value inside of a computer or inside of your own program. So how do I go about expressing myself in this way? Well, I think what I'm going to do is introduce a variable that's a little more interestingly named than x or y. I could just say this, x equals input, but I'm going to use a better name than a typical mathematical variable here, and I'm going to literally call my variable name. Why? Well, in programming, because I have a whole keyboard in front of me, I can use more descriptive terms to describe what it is I'm writing. And now, though, there's an opportunity to consider a specific piece of syntax. We've seen parentheses, we've seen quotes, all of which are necessary when passing inputs to a function. But this equal sign here that's in between input on the right and name on the left is actually important. And it's technically not an equal sign per se. It doesn't mean equality as much as it means assignment. So in Python and many programming languages, a single equal sign is the assignment operator. And what that means specifically is that you want to assign from right to left whatever the user's input is. So the equal sign copies from the right to the left whatever the return value of the function on the right is. So again, the input function clearly gets input from the user. That's why I was able to type my name or Carter's. But it also sort of behind the scenes hands that value, that return value, back to me, the programmer. And if I use an equal sign and a variable, no matter what I call it, I can store that input in that variable so as to reuse it later. So now sitting in the computer's memory somewhere is a container containing David, quote unquote, or Carter, quote unquote, or whatever the human has typed in. But here it's easy to make a mistake. Suppose I decide to try to print that name. And so I kind of, on a hunch, type in this, hello, comma, name, just kind of plugging in the name of the variable. Well, let me go ahead here and run python of hello.py and hit enter. That's going to prompt me for my name. And let me type in my name, D-A-V-I-D, but I haven't hit enter yet. And perhaps via the chat, what's going to happen here when I now hit enter? I'm hoping it says, hello, David. I'd be OK if it says hello, world. But I don't want it to say what it's actually going to say. And yep, what we're seeing in the chat is, well, it's probably going to say literally hello, comma, name. So that's not quite right. So we need another way of printing out the value inside of that variable rather than just this word name. Well, let me try this in a couple of different ways. Let me try this as follows. Let me go ahead and maybe undo this because I've gotten pretty good already at saying hello. So let's draw that line in the sand and just say, all right, let's at least get hello, comma, out the door. Let's now print name. And just on a hunch, I'm going to try this. I'm going to use print again, because you can use these functions as many times as you need. And I'm going to pass to the print function the variable called name. But notice, I'm being a little clever now. I'm not putting it in double quotes, because we've seen already that double quotes means literally print out N-A-M-E. I'm getting rid of the quotes this time in hopes that now by passing the variable called name to the function called print, it will in fact go about printing the contents of that variable, that is, its so-called value. All right, let's go ahead and do this here. Python of hello.py, enter. What's your name? David. And now, crossing my fingers still, I see hello, comma, David. All right, so it's not the best program. I'm kind of cutting some corners here, so to speak. I'm saying hello, David. on two separate lines. So it's not as elegant, it's not as pretty, it's not as grammatically appropriate in English as just saying it all in one breath on one line, but at least I've solved the problem, just not very well yet. But let me take a step back now and perhaps introduce a couple of other concepts with which we should be familiar, which is as our programs get longer and they're no longer just one line or two or even three, eventually our programs are going to become dozens of lines, maybe even hundreds of lines long. Let's set the stage for success moving forward. It turns out that Python and a lot of programming languages also support something called comments. Comments are notes to yourself in your code. And you include comments by way of a special symbol. In Python, it's going to be the hash symbol, typically. And that allows you to write the equivalent of a note to yourself, but in a way that's not going to break your code. The computer actually ignores your comments. It's just there for you. It's just there for your teacher. It's just there for your colleague with whom you're sharing ultimately that code. So if I go back to VS Code here, and I just want to add some comments to this program to explain to my teacher, to myself, to my colleagues what this program is doing, well, let's go ahead and do that. I'm going to go at the very top of my program. And on line 1 now, I'm going to move that original line of code down a bit. I'm going to add a hash. And I'm going to say something like this, ask user for their name. Now, I don't have to use that language. I don't have to use that text. I could use any human language whatsoever. It doesn't have to be English. But I'm going to now, below that, just say something like this, say hello to user. And you'll notice that VS Code by default is kind of graying out my comments. They're no longer blue. There's no red. There's no color in them. And that's just because they're notes to myself, and the computer ultimately is going to ignore them. But what we have now is two comments, ask user for their name, and then a second comment, say hello to user. And I've just kind of commented each chunk of code, like each line or lines plural of code that are doing something noteworthy. Why? Well, tomorrow morning when I wake up, having slept for quite some time, forgotten what it is I did the previous day, it's convenient with comments to just see in English or your own human language what it is this program is doing, so that you don't have to read the code itself. And better yet, if there's maybe a mistake down the road, you can read what your intention was, and then you can look at the code and figure out if your code's now doing what you intended. So this isn't really necessary for a program this small. It's pretty obvious with just 1 or 2 or 3 lines what the program's doing. It's just as fast to read the code than the comments. But getting into this habit is generally a good thing, to comment your code every 1 or few lines so as to remind yourself and others what it is your intent and your code is doing. What's nice about comments, too, is this. Comments can also serve to be sort of a to-do list for yourself. There's this notion in programming of pseudocode. Pseudocode isn't a formal thing. It's not one specific language. It's just using English or your own human language to express your thoughts succinctly, methodically, algorithmically, so to speak. But pseudocode, therefore, because it's not Python and it's not necessarily English, it just kind of allows you to outline your program even in advance. So for instance, if I wasn't sure today how I wanted to go about writing this program, but I did know what I want to do, I could have started today by just writing this in hello.py. No code. I could have written just a couple of comments to myself. Step 1, ask user for their name. Step 2, say hello to user. Then, once I've outlined my program in pseudocode, then I can go in there and say, all right, how do I ask the user for their name? Well, I can do input, quote unquote, what's your name, question mark. And then on the left here, I can maybe put a variable and assign it to that. OK, how do I say hello to the user? Well, I know I can use print to say things on the screen. Let me say hello, comma. And let me now print the person's name. So again, pseudocode is a nice way of structuring your to-do list, especially if you have no idea how to write the code, because it breaks a bigger program down into small, bite-sized tasks. All right, let me pause here to see if there are now any questions on comments, pseudocode, return values, or variables. Any questions we can clear up here?
Yeah, my question is, does the function input work for any type of information or only for words?
Yeah, really good question. So according to its documentation, and we'll look more at formal documentation soon, input is going to expect what's called a string. That is a sequence of text, be it in English or any other human language, but it's indeed going to be expecting text with which to prompt the user. A good question. How about another question from the group, if we could?
I wanted to ask how I make several line comment.
Oh, how do you do many lines of comments, if I'm hearing you correctly? Sure. You would just keep doing them like this. You just prefix each of the lines with a hash symbol, like I'm doing here. There is another technique for doing multi-line comments in Python that actually tend to have special meaning. You can do 3 double quotes like this, and then anything in between here is a comment. That's another technique, or you can use single quotes as well, but more on those, I think, another time. All right, well, if you don't mind, let me forge ahead here and see how we might improve this program further and also introduce a few other features that we might want to take into account over time. So it turns out that we can certainly improve on this program because it's a little disappointing that I'm cutting this corner and saying hello, comma, and then on a new line, printing out name. Like, we can do better. And most programs you use on your phone or your laptop certainly keep text together when people want. So how can we go about doing that? Well, there's a few different ways. And in fact, the goal here is not so much to solve this one problem, but to demonstrate and emphasize that in programming, Python and other languages, there's so many ways sometimes to solve the same problem. And here's one way to solve this problem. Let me go in here, and let me go ahead now and say hello, comma, and let me just add to the end of that the user's name. So I'm using plus in kind of an interesting way. This is not addition per se. I'm not adding numbers, obviously. But I do kind of want to add the person's name to the string of text, hello, comma. Well, let me go now down to my terminal window and run Python of hello.py again. Enter. What's your name? I'm going to type in David. Enter. OK, it's better. It's better, but there's a minor bug, albeit aesthetic here. There's missing space, but let's just use some intuition here. Well, if I'm missing the space after the comma, why don't I go ahead and just add it manually here? Let me now rerun the program, Python of hello.py, enter, David, enter, and there we go. Now we have something that looks a little prettier in terms of English grammar, hello, comma, space, David. And now if we rewind, you might have noticed before or wondered why I had this seemingly extra space after my question mark, namely here. There's a space after the question mark but before the double quote, and that was just for aesthetics too. I wanted to move the user's cursor one space to the right so that when I type their name, or they type their name, it's not immediately next to that same question mark there. But there's other ways we can do this. It turns out that some functions, print among them, actually take multiple arguments. And it turns out that if you separate the inputs to a function, the so-called arguments to a function, with a comma, you can pass in not just 1, but 2, 3, 4, 5, onward. So let me go ahead and pass in not just hello, comma, space, but that followed by name. And this is a little confusing potentially at first glance, because now I've got 2 commas, but it's important to note that the first comma is inside of my quotation marks, which is simply an English grammatical thing. The second comma here is outside of the quotes, but between what are now 2 separate arguments to print. The first argument is hello, comma, space. The second argument is the name variable itself. So let's see how this looks. Python of hello.py, enter. What's your name? David, enter. OK, I've kind of overcorrected. Now I've got 2 spaces for some reason. Well, it turns out, and this is subtle, when you pass multiple arguments to print, it automatically inserts a space for you. This was not relevant earlier because I was passing in one big argument to print all at once by using that plus operator. This time I'm passing in 2 because of the comma. So if I don't want that extra space, I don't need to pass in one myself. I can just do this. And now notice if I run this program again, Python of hello.py, type in my name, David, now it looks grammatically like I might want. Now, which of these approaches is better? This approach uses a function print with 2 arguments, hello, comma, and the name variable. The previous version, recall, technically used 1 argument, even though it looked a little curious. It's 1 argument in the sense that the computer, just like mathematicians, are going to do what's inside of parentheses first. So if inside of parentheses you have this string of text, hello, comma, and a space, which I need to add back, then you have a plus, which means not addition per se, but concatenation, to join the thing on the left and the thing on the right. This ultimately becomes the English phrase, hello, comma, space, David. And then what's being passed ultimately to the function is technically something like this. But it's doing it all dynamically. It's not me typing in David as I discreetly did earlier. It's figuring out dynamically what that value is after concatenating hello with the value of name, and then passing that ultimately to print as the sole argument. Let me pause here to see if there's any questions on numbers of arguments now to functions.
Can we use a function many times to solve a certain problem which we can encounter many times in our code?
You can. You can use a function many different times to solve some problem. What we'll soon see, though, is if you find yourself as the programmer solving a problem the same way again and again and again, it turns out you'll be able to make your own function so that you don't have to keep reusing the basic ones that come with the language.
I was curious about the comma and the plus sign. So after plus sign, can we give just one variable, and after comma, can we give multiple variables? Like, what is the difference?
A good question. So in the context of strings, and I keep using that term, string is a technical term in a programming language. And again, it means a sequence of text, a character, a word, a whole paragraph even. So the plus operator is not just used, as we'll see, for addition of numbers in Python like we do on paper pencil, but it also is used for concatenation of strings on the left and the right. If you did want to combine not just two strings, left and right, but a third and a fourth, you can absolutely keep using plus, 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 and chain them together just like in math. Eventually, that's going to start to look a little ugly, I dare say, especially if your line of code gets long. So there's better ways that we'll actually soon see. And a good question as well. Well, let me come back to the code here in question and see if we can show you just a couple of other ways to solve the same problem, along the way emphasizing that what we're technically talking about here, yes, are strings, but there's even a technical term for these strings. In Python, it's just str, so to speak, str for short for string. As you may know, if you programmed in other languages, people who invent programming languages like to be very succinct, to the point. So we tend to use fairly short phrases to describe things, not necessarily full words. So while you might say string, technically in Python, what we're really talking about, these sequences of text, are technically strs. This is an actual type of data in a program. But we'll soon see that there's other types of data in programs as well. In fact, let's see if we can't improve this in one other way. I like the progress we've made by keeping everything on the same line. Hello, comma, David. All on the same line. What more, though, could we do in terms of solving this problem? Well, it turns out that we didn't have to give up entirely with using print twice. Let me rewind a little bit and go back to that earlier version where I wasn't really sure how to solve this problem. So I was using print once to print out just the hello and the space and the comma. And then I used print again to print name. That, strictly speaking, wasn't bad, but there was this visual side effect that I just didn't like. It just looked ugly to have these two lines of text separate from one another. But there's another way to fix this. Clearly, it seems to be the case that the print function is automatically outputting a blank line. It's moving the cursor automatically for me to the next line, because that's why I'm seeing hello on one line and David on the next, and then my prompt, the $sign, on the line below that. So print seems to be presuming automatically that you want it to move the cursor to the next line after you pass it some argument. But you can override that behavior. Again, functions take arguments, which influence their behavior. You just have to know what those arguments are. And it turns out that if we look at the documentation for Python's print function, we can actually look up at this URL here. docs.python.org is where all of Python's official documentation lies. If I poke around, I can find my way to, more specifically, this URL here, where I can find all of the available functions in Python and the documentation therefore. And if I go a little more precisely, I can even find specific documentation for the print function itself. And rather than pull that up in a browser, I'm going to go ahead and highlight just one line from that same URL, which is this. And this is easily the most cryptic thing we've seen yet. But this is the official documentation for the print function. And one of the best things you can do when learning a programming language is honestly learn to read the documentation, because truly all of the answers to your questions will in some way be there, even though admittedly it's not always obvious. And I will say too, Python's documentation isn't necessarily the easiest thing, especially for a first time or a novice programmer. It too just takes practice, so try not to get overwhelmed if you're not sure what you're looking at. But let me walk you through this example. This, again, is a line of text from Python's official documentation for the print function. What this indicates as follows is this. The name of this function is, of course, print. Then there's a parenthesis over here and another closed parenthesis way over there. Everything inside of those parentheses are the arguments, the potential arguments to the function. However, when we're looking at these arguments in the documentation like this, there's technically a different term that we would use. These are technically the parameters to the function. So when you're talking about what you can pass to a function and what those inputs are called, those are parameters. When you actually use the function and pass in values inside of those parentheses, those inputs, those values are arguments. So we're talking about the exact same thing. Parameters and arguments are effectively the same thing, but the terms you use from looking at the problem from different directions when we're looking at what the function can take versus what you're actually passing into the function. So what does this imply? Well, this syntax is pretty cryptic. But at the moment, just know that an asterisk, a star, and then the word objects means that the print function can take any number of objects. You can pass in 0 strings of text, 1 string like I did, 2 strings like I did, or technically infinitely many if you really want, though that code's not going to look very good. After that, we see a comma. Then we see another parameter here called sep, short for separator in English. And notice the equal sign and the single quote, space, single quote. So quote unquote space. I don't know what that is yet, but I think we've seen a hint about it. Let's focus, though, for a moment on this. The print function takes another parameter called end, and the default value of that parameter is apparently, based on this equal sign and these quotes, \n. And what is \n, if you'd like to chime in the chat? Anyone who's programmed before has probably seen this, though if you've never programmed before, this might look quite cryptic. \n means new line. And it's a way textually of indicating if and when you want the computer effectively to move the cursor to the next line, create a new line of text. And so technically, if we read into the documentation, we'll see more detail on this. The fact that there's a parameter called end in the documentation for the print function just means that by default, this print function is going to end every line with \n. You don't literally see \n. You see a new line. You see the cursor moving to the next line. Now, by that logic, let's move backwards. Sep for separator. The default value of separator is apparently a single blank space. Well, where have we seen that? Well, recall in an earlier example, when I passed in not just 1, but 2 arguments to the print function, recall that they magically had a space between them. In fact, they had that space plus my own space, and that's why I deleted my space, because at that point it was extra. So this just means that when you pass multiple arguments to print, by default they're going to be separated by a single space. By default, when you pass arguments to print, the whole thing is going to be ended with a new line. Now, just by knowing this, and let me literally wave my hand at the rest of the documentation for another day. There's more things that print can do, but we're going to focus just on sep and on end. Let's see if we can't leverage this now to solve that original problem. The original problem was this. I don't like how hello, David is on 2 different lines. Well, that's happening again because print is automatically printing out a new line. So let's tell it not to do that. Let's tell it by passing a second argument to the first use of print to say end equals quote unquote, not \n, which is the default automatically. Let's make it quote unquote nothing else. Let's override the default value so there is no new line. There's literally nothing there. And let's see what happens. Let me now go down to my terminal window and clear it. And I'm going to run Python of hello.py enter. I'm going to type in my name, David. And I think now everything's going to stay on the same line because, and it did, this line here, 5, is going to print out hello, space, but then nothing at the end of it because I changed it to be quote unquote. The second line is going to print the name, David, or whatever the human's name is, and it will move the cursor to the next line because I didn't override the value of end there. Just to see this more explicitly, if you do something cryptic like, well, I have no idea what's going on. Let me just put in temporarily 3 question marks here. We'll see the results of this too. Let me go back down to my terminal window, run Python of hello.py, what's your name, David, and now you see literally really ugly output, but you see literally what's going on. Hello, space, then 3 question marks, end that print statement, and then you see DAVID. So not a good outcome, but it demonstrates just how much control we have here too. And let me rewind further. Recall that in our other version of this, when I passed in hello, and name, they were separated by a single space. So Python of hello.py, DAVID, enter. That just worked. Well, what if we override the value of sep for separator? Instead of being 1 space, we could say something like question mark, question mark, question mark, just to wrap our minds around what's going on there. Let me now do Python of hello.py, david, enter, and you see two. These two inputs, hello, comma, and the name are now separated in an ugly way by 3 question marks because I've overridden the default behavior of sep. And even though the documentation uses single quotes, I've been in the habit of using double quotes. In Python, you can use either. Strictly speaking, it doesn't matter, but you should be consistent. And I generally always use double quotes. Python's documentation, though, always uses single quotes. Questions now on these types of parameters. And allow me to propose that we give these an official name. Up until now, when we've been passing values to print, those are called positional parameters. Positional in the sense that the first thing you pass to print gets printed first. The second thing you pass to print after a comma gets printed second, and so forth. But there's also these things we've now seen called named parameters, named SEP, separator, or end, END, for the line ending. Those are named parameters because, one, they're optional, and you can pass them in at the end of your print statement, but you can also use them by name.
This may be a weird question, but I was wondering, what if someone wants to like add actually quotation marks within the quotation marks?
Yeah, I like how you think. This is what we would call a corner case, right? Just when we've made, right? This is all sounding great, at least as programming goes. But wait a minute, what if you want to print a quote? That's a really good question. Well, let's see if we can't figure this out. Suppose that I want to print out not just the user's name. Let me simplify this further. Let me go ahead and get rid of a lot of this. And let me just say something like, hello. Maybe I'm being a little sarcastic here. Hello, friend. You know, in that kind of tone. Well, this is not going to work, actually, because you are trying to use quotes to be like friend in finger quotes, but you're also trying to end the sentence. And if I try running this, let's do this. Python of hello.py, you'll see that this is just invalid syntax. Perhaps you forgot a comma. And this is actually a bit annoying. Sometimes the error messages you see are misleading. Like the computer, the language doesn't really know what's going on, so it gives its best guess, but it's not necessarily correct. But I can solve this problem in a couple of ways. I can do this. I can change my outermost quotes to single quotes, because recall a moment ago I said you could use double quotes or single quotes so long as you're consistent. So that's fine. If you use single quotes on the outside, you can then use double quotes on the inside, and you'll see them literally. So for instance, if I run Python of hello.py, there we go, hello, friend. But there's another way. If you insist on using double quotes, as you might want to, just to be consistent, you can also use that backslash character again. We saw the backslash n a moment ago, and that meant we don't want a literal n to be in the output. We wanted a new line. So the backslash actually represents what's called an escape character. An escape character is one that you can't just type necessarily once on your keyboard. You need to express it with multiple characters. So I can actually put backslashes in front of these inner double quotes so that the computer realizes, oh, wait a minute, those aren't quotes that finish or start the thought. They're literal quotes. So now let me go back to my terminal window, run Python of hello.py, enter, and now it's working as well. So escaping is a general technique that allows us to do that too. And if I may, let me rewind now on these examples and go back to where we left off with my code. I'm just undoing all of that because I want to get back to the point ultimately of specifying now a final way of solving this problem. Well, it turns out that we have yet another way we can solve this problem, which is perhaps the most frequently done now, or at least the most elegant when it comes to setting us up for longer and longer uses of strings. You can use a relatively new feature of Python that allows you to do this. You can literally put not the name of the variable like that in your string, because we already saw this is wrong, right? If you do this, you will literally see hello, comma, name. But what if I do this? What if I put curly braces or curly brackets around the variable's name? Notice VS Code is actually very subtly changing the color of it. So VS Code knows something interesting is going on here. Let me run this program, but I'm not done yet. Python of hello.py, enter. david, enter. OK, obviously not what I want. But I need to tell Python that this is a special string. This is what we're going to call a format string or an F string, a relatively new feature of Python in the past few years that tells Python to actually format stuff in the string in a special way. And the symbol via which you do this is a little weird, but this is what the world chose. If you put a F at the beginning of the string, right before the first quote mark, that's a clue to Python that, ooh, this is a special string. Let me format this in a special way for you. Let me now rerun the program. Python hello.py, enter, david, enter, and now we see the goal this whole time, hello, comma, David. We don't start with this way because I think if we did this the first way, you'd be like, why are we doing this? What are all these magical symbols? But this is just yet another way to solve the same problem. But let me propose that we consider now yet other things we can do with strings. And it turns out that even as we've been doing some relatively simple operations here, we've generally been trusting that the user is going to cooperate. And that is to say that they're going to actually type in what we want them to type. Now, just because they type a string, though, doesn't mean it's going to look the way we want. You and I, honestly, as humans, are actually in the habit on websites and apps of like accidentally hitting the space bar a lot, either at the beginning of our input or at the end. Maybe because the space bar tends to be so big, it's pretty common to get accidental spaces before or after some user's input. You and I are definitely in the habit of not necessarily capitalizing words like we should. If we're sending text messages, we're probably being a little quick and just sending everything in lowercase, for instance, if that's your style, if your phone's not fixing it for you. Maybe in a formal letter, you would capitalize things properly. But you and I, as humans, we can't really be trusted to type things in a nice way necessarily when using some piece of software, be it an app or a website or something else. But it turns out that strings themselves come with a lot of built-in functionality. And you can see all of that in Python's own documentation here. The string data type that we've been talking about comes with a lot of functionality built in that means that we can manipulate the user's input to do more than just join it with something else, like hello. We can actually clean it up or reformat it in a way that hopefully looks a little better for us. So let me go back to my code here, and let me just demonstrate what might happen if a user doesn't cooperate. If I go ahead here and run Python of hello.py, enter, let me just sloppily hit the space bar a few too many times. Why? I just wasn't paying attention. And now I'm going to type in my name, david, and I don't know, I hit the space bar a couple more times. Like, it's kind of a mess. It's all lowercase. That's not going to necessarily look grammatically right. It's got spaces here and here. The program is going to print exactly that. And that looks really bad, at least if we're prioritizing aesthetics and grammar. Like, why are there so many spaces after the comma? This is not a very nice way to greet your users. But we can clean this up. It turns out that built into strings, which again is this data type, so to speak, this type of data in Python, is the ability to actually do things to that string. So let me do this. I can actually go ahead and do something like this. Name equals name.strip. And what does this do? Remove white space from string. And what do I mean by this? Well, on the right-hand side, notice I've written the variable name called name. I've then used a period or a dot. And then I seem to be doing what's a function, right? Anytime we've seen a function thus far, we see it's the function's name, print or input. Then we see a parenthesis, then another parenthesis. And that's exactly what I see here. But I'm using this function a little differently. Technically, this function is, in this context, called a method. And what do I mean by that? Well, if name is a string, aka stir, well, it turns out, according to the documentation, there's a lot of functions that come with strings in Python. And you can access that functionality by using the name of a string, like literally name here, then a period, then the name of the function, and then an open parenthesis and a close parenthesis. Maybe some arguments inside of those parentheses, but in this case, it doesn't need any arguments. I just want to strip the space from the left and the space from the right of the user's input. But that's not enough. I want to remember that I've stripped off that white space on the left and the right, so I'm going to use the equal sign again here. And notice that just as before, this doesn't mean equality. This means assignment from right to left. So when this line of code here, name.strip, returns to me, aka a return value, it will return the same thing that the user typed in, but with no more white space to the left or to the right. So then the equal sign assignment is going to copy that value from the right to the left, thereby updating the value inside of my name variable. So you can not only assign values to variables, you can absolutely change the value of variables by just using the assignment operator, the equal sign, again and again and again. And it will just keep copying from right to left whatever the new value should be. So now, if I rerun this program, Python of hello.py, enter, I have DAVID, oh, let's do it again. Space, 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 DAVID in all lowercase, space, space, enter. It's better. It hasn't fixed my capitalization, so I'm still being a little sloppy with the first D, but it has stripped off all of that extra space. Super minor detail, right? Like this isn't all that exciting, but it just speaks to the power of what you can do with just a single line of code. Now, what else can I do here? Well, I could capitalize the user's input. Let me go ahead and try this. It turns out that I could also do this, name.capitalize. So let me go ahead and capitalize user's name. And again, I'm making comments, and there's no one right way to write the comments. I'm just using some short English phrases here to remind myself of what I'm doing. What's now going on here? Well, let me go ahead and run Python of hello.py, enter, space, 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 DAVID, space, space, enter. OK, now it's looking prettier, right? No matter how the user typed in their name, even a little sloppily, I'm now fixing that. But let's try something. I'm getting a little curious here. How about this? Space, 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 DAVID, space, Malin. I'll use my last name now. Enter. OK, so ironically, capitalize is not really capitalizing everything we want. It's clearly capitalizing what? Just the very first letter. So it turns out that, again, there's other functions in Python that come with strings. And if we poke around the documentation, scrolling through a URL like that, I bet we'll find another solution, one of which is actually this. Let's actually change this to title. There's yet another function that come with strings called title that do title-based capitalization, just like a book or a person's name, capitalizing the first letter of each word. And this is just going to do a little more work for us. So let's go ahead and run this. And as an aside, I'm kind of tired now at this point of typing Python, Python, Python all the time. It turns out that when using a command line interface like this, you can actually go back through all of your old commands. What I just did a moment ago was I hit the up arrow. That immediately goes back through my history of all of the commands I've ever typed. So this is just a faster way now for me to repeat myself than typing everything manually. Let me go ahead and hit enter. Space, 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 DAVID, Malin, space, space, all lowercase, enter. Now it's looking better. Now I've capitalized things and cleaned things up. But what about my code? I've got like 8 lines of code now, 4 of which are comments, 4 of which are actual code. Do I really need this much? Well, not necessarily. Watch what I can also do in Python. Let me not bother capitalizing the user's name separately. Let me say this, and capitalize user's name. I can chain these functions together. I can add title to the end of this. And now what's happening? Well, again, with a line of code like this, you first focus on what's to the right of the equal sign. Then we'll get to the left of the equal sign. What's on the right of the equal sign? This line here. Well, what does this mean? Get the value of the name variable, like DAVID space MALIN, then strip off the white space on the left and the right. That is going to return a value. It's going to return DAVID space MALIN without any white space to the left or right. What do you want to do with that return value? You want Python to title case it. That is, go through every word in that resulting string and fix the first letter of the first word, the first letter of the second word, and so forth. And then, now we can finish our thought, copy the whole thing from right to left into that same name variable. And you know what? I can take this even one step further. Why don't we go ahead and do this if we want? Let me get rid of all that, and let me just do strip and title all on that first line. And now we've gone from like 8 lines of code to 4. It's a lot tighter. It's a lot neater. And even though reasonable people might disagree, it's arguably better because it's just easier to read. Fewer lines of code, fewer opportunities for mistakes. It just allows me to move on with my next problem to solve. All right, let me pause here and see if there's any questions on these methods. A method is a function that's built in to a type of value, like these functions are, or on f strings, which we saw a moment ago.
Yes, hi, thanks, David. So is there a way to remove the spaces between the spaces that I might have added?
Short answer, no. If you read the documentation at that same URL earlier, you'll see that strip removes from the left and the right, but not in between. In fact, there's two other functions that come with strings. One's called lstrip, the other's called rstrip, that allow you to do one or the other. If we want to start getting rid of space in the middle, we're going to have to do a different trick altogether.
How many functions can we combine like this dot strip, dot title you have combined? So how many we can combine?
Yeah, a really good question. Technically, as many as you want. But at some point, your code's going to start to look really, really bad, right? Because the line of code is going to get really, really long. It's eventually going to maybe wrap around again and again. So at some point, you just kind of say like, that's too many. And you start breaking it up into multiple lines like I did, maybe reassigning the value to the variable as needed. And this is actually a good question. If I can pivot, Divya, off your question, I mean, what do people think? If we could go ahead and put everyone's hands down for a moment, let me ask this. Is the way I've done this now with strip and title and input all in the same line better than my previous approach? In Zoom, you can use the yes icon or the no icon. If you think this version is better, say yes. If you think this previous version was better, for instance, this one here, where we had everything broken out, say no. And then we'll see why in just a moment. I proposed earlier that reasonable people can disagree, and that's absolutely the case. Doing it one way or the other isn't necessarily best, at least if you can justify it. Let me go back to the most recent version here. All right, so we're seeing a lot of yeses and a lot of nos. Why don't we go ahead and call on one of the yeses if we could? Someone who's voting yes, why do you think the current version of this code is indeed better than the previous longer version of the code?
I think it's more readable, so I can say, hey, this is the name variable. It gets some input, and then remove the space and give it a title, and there you go. You have a hello name.
Yeah, I think that's pretty reasonable. It's very readable, at least if you're in the habit, as you are in English, of reading left to right. It just kind of flows very naturally as a result. The line is not really that long. It's certainly fitting nicely onto the screen, so I think that's a good argument. How about a counterpoint, though? Someone who voted no, if we could call on someone who thinks this is worse.
Because it's not readable at all. It seems like it's a very long line, so I think it's better to separate.
Yeah, I think that's persuasive too, right? It's getting a little longer. And even though my sentence here, what's your name, is relatively short, you could imagine that this could get even uglier quickly. If I were asking a longer question of the user, that's going to make this line of code even longer and therefore less readable. It might be less obvious to me or my colleagues that I am calling strip or that I am calling title. It might be kind of an unexpected surprise. So I think that's reasonable too. In short, there is no right answer here. And in fact, part of the process of getting better at programming is getting your own sense of style, or working for a company where they might prescribe which way is better than the other because they just want everyone doing the same thing, even though reasonable people might disagree. Ultimately, though, so long as you have what's a pretty good argument in favor of one way or the other, like ultimately that's what's important. If you're just doing things because you don't really know which one's better, that's not great. But if and when you start to acquire opinions, and if your boss, if your teacher, if your colleague, your friend can challenge you and say, wait, why did you do it like this? They might not agree with you, but at least have an answer, and that should be sufficiently persuasive in general. Now, strings come with a whole bunch of other methods as well, among which is one called split, which can, as the name suggests, split a string into multiple smaller substrings, so to speak. For instance, if the human here is in the habit of typing in their first name, then a space, and then their last name, and you want to go ahead and greet them only by first name, well, we could actually leverage that single space between the first name and last name and split that string into two smaller substrings. How can we do this? Well, let me go ahead and in between these lines proactively comment that we're about to split user's name into first name and last name. And then let's go ahead and take that name variable, which currently contains something like, presumably, David space Malin. And let me go ahead and call split and pass in as the argument to split a single white space, thereby indicating that I indeed want to split on that character. Now, it turns out split's going to return a sequence of values, ideally a first name and then a last name. And we can actually, in Python, assign both of those values from that sequence at once to some variables. For instance, first, comma, last equals. And that's going to have the effect from right to left of putting the first such value in the first variable, the second such value in the second variable. So now on my last line of code, I can go in and say hello, not to the full name, something like David Malin. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Malin, and crossing my fingers as usual, hello David is what we now see. All right, so we've seen so many examples thus far involving strings, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str, str is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like -2, -1, 0, 1, 2, and all the way toward negative infinity, all the way toward positive infinity. But there's no decimal point in an integer. It's just a number like -2, -1, 0, 1, and 2 onward. That's an int. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen plus before, although we used it for a different purpose. But Python supports these symbols and more. And Python allows you to add numbers together, plus, subtract numbers, multiply numbers, divide numbers. And the only one here that might look a little strange to people or unfamiliar is this % sign, but it doesn't mean percent in this context. If you use a single % sign in a Python program, that's actually the so-called modulo operator, the operator that allows you to take the remainder after dividing one number by another. So we'll see examples of that before long, but the first 4 of these are perhaps quite familiar. Well, it turns out that in Python, you don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window. One of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive mode for Python. So I'm running the Python interpreter. And anytime I type a line of code in the interpreter, it's going to execute it immediately. I don't have to keep running Python again and again. It's as though in the human world, if you were standing next to a human who speaks some other language and you're just having a conversation with them back and forth, it's all happening, the translation immediately. So what might I do in interactive mode? Well, I could do something like 1 + 1, enter. That's actually code. All right, you might not think of it as code, but if you know a bit of arithmetic and you know numbers and you know plus, that's valid Python code. And you can use Python really as a fancy calculator. But I could do other things too. If I want to print to myself hello, world, I can also print out that line of code there too, hello world. So it's interactive in the sense that the moment you execute a line of code, boom, you see the result. We're generally not going to do that because at least when teaching the language, we tend to want to do things incrementally. And we want you to be able to see where it is we came from. And we want to be able to try things again and again, especially if we make mistakes. But know that this is indeed a feature of Python, this so-called interactive mode. But let's focus for a moment now, not just on that interactivity, but really on the fact that Python apparently supports integers and mathematics and some of those basic operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file so that we can iterate on this and make changes for better or for worse over time. Let me go ahead and first declare a couple of variables. I'm going to do the mathematical thing of calling my first variable x, my second variable y, And then I'm going to give myself a third variable, z equals x plus y. And then I'm going to go ahead and print out z. Now, this program, admittedly, not very exciting or interesting. In fact, it's a little less interesting than printing stuff on the screen like before with strings. But we'll build on this and see what other features exist in Python that we can leverage. So hopefully, if Python knows its math as well as I do, when I run python of calculator.py, I should see, hopefully, that 1 plus 2 equals indeed 3. All right, so not that surprising and not that interesting. And honestly, this isn't the most useful program because it's always going to calculate 1 plus 2 equals 3. Let's at least make this program, say, a little more interactive, right? We already know from previous examples how we can get input from the user. Let's bring back that input function. And let's do this. Let me go ahead now, and at the top of my code, let's change x to not be the number 1 always. Let's change it to be whatever the return value is of asking the user for x. And I can use any English or human language I want here. I'm going to say, what's x? Just like I asked before, what's your name? And I'm going to do the same thing for y. I'm going to use input again, but this time change the question to be, what's y? All right, at this point, I think I'm going to leave the rest of the code the same, z equals x plus y, and then print z. But what's nice now is that I think I have a nice interactive calculator. Right now, it's not going to do 1 plus 2 all the time. It's going to do whatever the user types plus whatever the user types. So let's try this. Let me go ahead and run the program. All right, let's do it. 1 is going to be x. 2 is going to be y. And of course, everyone in agreement, 1 plus 2 equals 3. Huh. What's going on there? Either your math class misled you or I have misled you. Why don't we call on someone here to see if you can't help us reason through what the bug is? What's the mistake? Anjali, if I'm saying it right?
I think the issue is that it's concatenating strings because you use the plus operator instead of adding.
Perfect. So perfect intuition. We've seen that plus is used a little differently in the context of strings because it concatenates. That is, it joins the two strings. And that seems to indeed be what's happening here, even though the user typed a number. But the interesting thing here is that when you get user input, because they're using a keyboard on their Mac or PC or their phone, it is always going to be text. It might look like a number, but by default, it's coming from the keyboard as a string. That is as text. And so how do we go about resolving this if ultimately we don't want to treat those inputs as strings? We want to treat them as actual numbers. Well, we need another function. And it turns out in Python that you can convert sometimes from one type of data to another type of data, for instance, from string to int, by doing something like this. Let me go back into my code and let me change x before adding it to y to be whatever the integer version of x is, plus whatever the integer version of y is. So it turns out that int is not only a type of data in Python, it's also a function. And it's a function that if you pass in an input, like a string, so long as that string looks like a number, like 1 or like 2, it will convert it to an actual number that you can perform mathematics on instead. So if I now go back to my terminal window and run Python, and let me show you another trick. Calculator is kind of a long word. It's a little tedious to type. Notice what I can do in my terminal window in a command line interface in general. If I start typing CAL for calculator, I can actually hit tab to finish my thought. So autocomplete is possible in a terminal window like this. Type the first letter or few letters, and then boom, with tab, it'll finish your thought for you. Or you can go back in your history like I did with the up and down arrows. Let me go ahead and execute this. What's x? 1. What's x2? And there we go. Now we have a general purpose calculator that's going to support not just addition of 1 and 2, but now any two integers that the user types. And let me now improve this, right? We've seen how we can make improvements to code. And I don't know if it's going to necessarily be better, but let's try this. Do I really need the z variable? It's worth noting that I'm creating a variable called z, and then I'm immediately using it on the next line of code. Now, that's not that compelling because if you're creating a variable and then immediately using it but never again using it, did you really need to take the time to introduce another symbol and another variable just to use it once and only once? Well, maybe not. Maybe we don't really need z in this way. Maybe I should go and do something like this. Maybe I should get rid of z here. maybe I should change this to be int up here, change this to be int up here, doing something that's pretty interesting now. Even though it's a bit of new syntax, notice that you can nest functions, so to speak. You can put one function call, that is the use of a function, inside of the use of another function so that the return value of the inner function becomes the argument to, or the input to, the outer function. So just like in math, if you have parentheses, 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 your teacher probably taught you to focus on what's inside the innermost parentheses first and then work your way out. Same thing with programming. That's what Python's going to do. It's going to look at what's inside of the parentheses first. It's going to get the answer, and then it's going to pass the return value to the outermost function. So what happens on line 1 now is that the input function gets called first. Then the result of that, quote unquote 1, becomes the input to the int function. And same on line 2. The output of what's y becomes the input to this int function. And now there is no z. I could just do print x plus y. And because I've taken the time to convert each of those strings to an integer, I think we're OK. So let me try this. Python of calculator.py, enter 1 and 2. And we're still getting 3. Not 12, or not 12, 1, 2. We're indeed getting 3. And we've additionally gotten rid of the variable because we didn't necessarily need it, it seems, especially if only using it once. Well, here too, let me put everyone's hands down for just a moment, and let me ask, as before, this version now, which uses int around the invocations of input and does not use z, is this better than the previous version? If you want to vote yes, go ahead. Or if you prefer the old way, vote no. The old way, I'll undo all of this as we vote, instead looked like this. All right, and let me go back to now the newest version. Let's take a hand of the yeses. Someone who thinks this latest version is better.
I think this way is better because it allows us to immediately see what the x and y variables are with integers, and so we know what to expect from them. And also the print argument is more intuitive. We avoid too much clutter in the code.
I think those are all good reasons. It's nice and succinct. The lines of code are not very long. I don't need to know what z is because it doesn't exist. It just see print x plus y. I like that. But someone who prefers the older way, where we did have z, and we more explicitly passed individual variables to the int function.
Yeah, hi. I think the earlier version is better because when, if user input something else other than int, let's say they type 1 and 2, so it will be easier to debug.
This version, or this version here, or the old version?
The old version.
OK, that's fair. And in fact, I'm being very careful today as best I can not to mess up. I have thus far only inputted integers when I'm expecting integers. And Raul's actually pointing to something we'll come back to in the coming weeks. How do we actually handle errors? What if the user doesn't type in the number 1 or the number 2 or a number at all? What if they type in a word like cat, C-A-T? That's not a number, and I bet I can't convert it to an integer. But for today, I'm not going to focus on that. I'm just going to hope that the user cooperates, but that's not going to be the case. And so perhaps one way would set us up for more success when it comes to handling those errors. Now, for today's purposes, which is better? I like both. And I think both of you made very valid arguments in there too. So long as you have a justification that feels pretty reasonable, that's what ultimately matters. But acquiring, again, a sense of the trade-offs here. Well, is this way better? If so, why or why not? Just understanding what those trade-offs are. But generally speaking, prioritizing readability is a very good thing. Making your code readable for someone else is a very good thing, and very good for you too, so that when you wake up the next morning or you come back the next week or the next year, you too can read your own code without having to waste time trying to remember what you did. And simplicity tends to be a good thing too, keeping your code simple. So as you get more comfortable with programming, you might be tempted to try to combine an entire program into one long line. For instance, let me do just that. Technically speaking, we don't really need x in a variable. We don't really need y in a variable. We could also do this. I could just get rid of x and y altogether. I could then now eliminate that and make it just one line of code. OK, so in some sense, you might be inclined to think, wow, that's really nice. You made it one simple line of code. I would argue this actually isn't that simple. Now I think I'm starting to nest too many things. I have to think about print and int and input. I then have to notice that, OK, I've opened 2 parentheses. I've closed 2 of them. There's a plus. You're making me think too much. And anytime you make me think, you're wasting time. And anytime you complicate the look of the code like this, you're just going to increase the probability of mistakes, syntactical mistakes or logical errors in your code. So of all the things we've done, this is the only one that I would argue, yes, it's one line and it's nice and compact. It's just not readable enough. I would shy away from doing this, especially since 2 of those function calls are getting input from the user. But there too, reasonable people might disagree. But that's the kind of like visceral reaction you should have sometimes when code starts getting a little too complicated, a little too clever, perhaps for its own good. All right, well, it's not just integers we have access to. Let me propose that we transition from integers to one more data type here, namely a float. So again, a string is a sequence of text. An int is an integer, like -1, 0, and 1. A float is a number with a decimal point, properly called a floating point value. And you can think of the floating point as being the decimal that might be over here or over here with some number of digits to the left or the right. Mathematically, it's a real number, a number that has a decimal point in it. So that's a third type of data that Python supports. Right now, our calculator is somewhat naively assuming that the user is only going to type in integers. But if I want to support floating point values too, I think I can just make a couple of tweaks. So I'm going to go back to VS Code here. And instead of just converting the user's input, x and y, to integers on line 1 and 2, let's just make a simple change. Let's actually convert it to a float on the first line and a float on the second line here. Now I think if I go down to my terminal window and run Python of calculator.py, let's type in a number like 1.2 with a decimal point and 3.4 with a decimal point, and there we go. We have 4.6 as the final answer. So that wouldn't have worked before if I was only expecting integers from the user, but now that I'm expecting floating point values and accommodating it, I can actually now do floating point arithmetic as well. But suppose that I don't really want the final answer to be a floating point value like 4.6. I would be happy if we just round to the nearest integer. So I want to support the user typing in floating point values with decimal points. But at the end of the day, I just want to round the result to the nearest possible integer, for instance. Well, it turns out that here too, Python comes with some functionality built in. And in fact, if we return to this URL from earlier, wherein all of the Python built-in functions are listed, there's one called round, which does exactly as we would expect. It takes as input a number and then rounds it for us, for instance, to the nearest digit, to the nearest integer. But if we look a little closer at that documentation, as we can here, I'll provide an excerpt. This is what the function looks like in the documentation. And recall that earlier we looked at the documentation for print, and this is similar in spirit, that this shows us not just the name of the function, but its available parameters. That is, inputs that we can provide when using this function. But this is a little cryptic too, just like print was, and it adds some syntax. So let's see. The name of this function here is, of course, round. And its first argument is a number. Notice this time there's no star. There's no star objects like there was for print. The round function takes just one number as its first argument, period. That's its positional parameter. But notice this syntax. And this is a convention in programming or technology more generally. Generally speaking, when you see square brackets in documentation like this, this means that you're about to see something optional. And so what this means is that if you want to specify more precisely the number of digits that you want the round function to round to, you can specify it here by adding a comma and then that number. So if we read the documentation, if you don't specify a number of digits, you just specify the number to round, it rounds to the nearest integer. But suppose you want to round to the 10th place or the 100th place, that is 1 or 2 digits after the decimal point, you could additionally pass in comma 1 or comma 2 to be more precise. So that's what the documentation there is saying. Let's see if we can't then translate this to some actual code for us. So if I go back now to VS Code and I consider that I want to go ahead and round x and y, I can do this in a couple of ways. I could do round x plus y, but you know, I'd actually kind of prefer to break this now out into 2 lines. I don't have to, and reasonable people here might disagree, but I'd like to revert to a scenario where I'm printing z so that I can just a little more clearly to myself, to others, say z equals the rounded result of x plus y. It's not necessarily the better way to do it, but I'm a little more comfortable with breaking out my thoughts one at a time, especially if I want to start commenting each of these chunks of code. All right, let me go down to my terminal window now and run python of calculator.py. What's x? Let's do 1.2 again. Then let's do 3.4. And now it was previously 4.6, but now it's been rounded up to the nearest integer, which of course is going to be 5. All right, what if I wanted to change this a little further? What if I wanted to support maybe really big numbers, irrespective of rounding? Let's just do something like this. Let me go ahead and run python of calculator.py again. And let me just add 999 plus 1. And notice I don't have to type decimal points. Even though I'm converting to float, my program will just allow me to type decimal points, but I don't need to oblige. The answer, of course, here should be, and is in fact 1,000, whether or not we round. So that's just arithmetic with integers here. But in the US, we tend to format long numbers by putting commas after or before every triple of digits. Other countries flip it and they use periods and commas instead. That's a system setting. You can change that on your own Mac or PC or device for Python or any language. But for me, I'm using the US approach here, which is periods for decimal points and commas for separators. What if I wanted this to be outputted as 1, 0, 0, 0? Just to make it a little more clear that it's 1,000 and not something like 100. That's even more useful when it's like 1,000,000, 1, 0, 0, 0, 0, 0, 0. Wouldn't it be nice if we could automatically output those numbers as well? Well, it turns out that we can. There is a way using Python to actually specify that we want to include commas like this. And here we have an opportunity to bring back our old friend, the f string. First, let me do something that's not that productive. First, let me do this. Let me print out the value of z. But wait a minute. I can't just say quote unquote z, because that's literally going to print z on the screen. So let me wrap it with those curly braces like I did before. But that too was not enough. I literally needed to add an f at the beginning of my string to tell Python that this is an f string, a format string. That now is going to print out, not very interestingly, just the value of z itself. So that I'm going to great lengths just to print z, when really I could have just passed z as the sole argument. But just to ensure that I haven't broken it, let's do this again. 999 plus 1, enter. OK, it's still 1,000. So I didn't make anything worse. But notice, and this syntax is unfortunately a bit cryptic, notice that I can actually do this. I can put a colon after the z, and I can put a comma thereafter. This looks very cryptic, admittedly. And even I have to constantly look things like this up in the documentation to remember the syntax. But here, let me run it again. Python of calculator.py, 999, 1, and now notice that the number has been automatically formatted for me. If I were in a different country or locale, I could absolutely override this to use periods instead of commas or vice versa. But in this case here, it's just happening for me automatically. So there too, we see a hint of what it means to really format a string. There's even more power, more powerful capabilities built into that. All right, let me pause here to see if there's any questions now on floats, on rounding, or on this use of f strings.
Yes, so I have a question. So when using floats, is there like a cap to how many decimal points it can have?
A really good question. So floats, yes, and this is a problem we'll revisit before long. Floats cannot represent numbers infinitely precisely in a nutshell because computers only have so much memory. They only have a finite amount of memory. You and I only have a finite amount of hardware inside of the computer. So at some point, they're going to have to round. Right now, I'm rounding automatically. Effectively, computers will eventually have to do that for us. But we'll see that as a fundamental problem before long. Allow me to turn back just for a few final examples on float before we introduce a few final examples that allow us not just to use functions, but to make our own. Let me propose that we also try our hand at a bit of division here. Let me propose that we modify this calculator now to still take a couple of floats, but let's now just do something a little simpler than a little different from this, just doing x divided by y. And let me go ahead and get rid of my format string and just keep it simple for now, printing out z instead. And what are we going to see here? Well, just some simple division. So Python of calculator.py, let's do something like 2 divided by 3. And of course, I get 0.66666. And to Ethan's question a moment ago, it does seem to be finite. It's not rounding in a weird way here, but I only seem to see so many digits. That's an inevitability of using a float in this way. By contrast, just so you know, integers nowadays in Python can be as big as you want them to be. Unlike other languages, there is no upper bound on how big an int can be now in Python, but there is a bound on just how precise a floating point value can be. All right, now that I've got some simple division working here, let's go ahead and round this. It would be nice to round this really long number, 0.6666666, and so forth, to maybe just 2 decimal places. We've seen how to do this with round, though, at least in its documentation. Let's just round this, not to the nearest int, by passing in just x divided by y, which is 1 argument. Once the math is done inside of the parentheses, I don't want to pass in just 1 argument. I want to pass in 2 so that I can specify n digits, number of digits, which recall was the second parameter for round. Let me go ahead and run python of calculator.py. I'll do the same thing, 2 and then 3. 0.67. So here too we see a way of rounding now, not just to a nearest integer, but to a nearest number of digits. But there's another way to do this here. And in fact, this evokes our f string example again. Let me go ahead and change this. Suppose that you didn't remember the round function, or for some reason you didn't want to use it. You instead want to just use a format string. Well, let's go there. Let me do quote unquote z. But let me surround it with those curly braces. Let me add the f at the beginning. And again, this is not interesting yet. This is just going to print out z, but I'm adding a lot more complexity to turn it into an f string. But notice, I can do something else after my variable name, after the colon. If this were going to be a big integer, I might want to use a comma like before to separate each triple of numbers with commas. But I don't. I'm going to use a different sequence of characters. I'm going to say 0.2f. And this, too, is one of these very cryptic things I have to constantly look up because I forget if I don't use it that often. So don't be intimidated if this looks especially weird. But this is, according to the documentation, the way you specify using an f string how many digits you want to print. So let me run this version of the calculator. Type in 2 and then 3. We get the exact same thing. But again, this is just consistent with my claim that in programming, we can so very often solve the same problem in multiple ways. This is just now the f string approach to that very same problem. All right, which one is better? It depends. In this case, they're pretty equivalent. You could imagine, though, it being useful to use a function sometimes so that you can pass in an argument like n digits as that second argument. Or you can imagine just deciding in advance that you want 0.2 and then writing it like this. Let's transition now from focusing on strings and on integers and on floats to focusing now on functions themselves. We began today by focusing on how you can use functions that come with Python. But wouldn't it be nice if you could invent your own functions, especially if, to our point earlier, you find yourself solving the same kind of problem again and again? It's nice that Python comes with the print function because it's really useful to be able to print things on the screen. But wouldn't it be nice if you could print specific things on the screen by just calling your own function? Well, let me propose that we do this. Let me go back to VS Code here, and let me propose that we go back to hello.py. I'm going to reopen hello.py where we left it before, and I'm going to go ahead now and propose that we consider how we can start improving this further by making our own function. I have written so many programs today that just say hello. And each time I'm using print, but wouldn't it have been nice if from the beginning of today we could just call a function called hello that just says hello for us? Now, the authors of Python years ago didn't think that we need a special function just to say hello, but I would like that to exist. I'm saying hello so many times, I just want to be able to call a function hello. So I'm going to start from scratch here. I'm going to delete all of my code from earlier, and I'm going to pretend for the moment that a function called hello exists. And I'm going to do just as I did before. I'm going to get the user's name with the input function, asking what's your name, question mark. And now I'm going to call a function hello, and then I'm going to print out the user's name. Now, I will admit hello doesn't exist, so bad things are about to happen, but let's see what. Let me go down to my terminal window. Let me run python of hello.py. I think the first line is going to be OK, because that worked before. And indeed, it's prompting me for my name. So let me type in David. The second line of code is apparently calling a function that looks like it's called hello, because why is it a function? It has a parenthesis and a close parenthesis immediately after it. And that's what every function we've used has looked like But Python's not going to recognize this one. When I hit enter now, I get a name error. Name hello is not defined. Did you mean help? I didn't, although it's opportune. That's what I need at this point, is some help. But I am encountering this error because why? The function just doesn't exist. So how do I make this function exist? Well, I need to create it myself using this keyword, def. Def for define. So here too, just as str is short for string and int is short for integer, def is short for define. If and when you want to define, create, invent your own functions, you can do so using now this keyword in Python. So let me go back to my code here, and let me propose that we define this perhaps in this way. At the very top of my file, I'm going to first take a moment to define a function called hello using def hello, open parenthesis, close parenthesis, colon. What this means now is that Python is going to treat every line of code that I indent underneath this one as the meaning of this new function hello. So def is important, as is the space. I get to choose the name of the function, and I'm choosing to call it hello. The parentheses with nothing inside means that this function at the moment is not going to take any inputs. No arguments there too. The colon means stay tuned for some indentation. Everything that's indented beneath this line of code is going to be part of this function. It's going to be a super short function. One line of code. It's just going to print out, quote unquote, hello. But now, on lines 1 and 2, I have invented my own function, hello. Notice these dots that have now magically appeared here. This is just a setting of my text editor, VS Code in this case, that's just making super explicit to me that I've hit the spacebar 4 times, or equivalently the tab key once, which is converted automatically to 4 spaces. Generally speaking, I'm going to need to make sure that all of my indented code lines up now so that Python knows that it's all part of the same thing. But it's easy in this case because it's just a single line. But now, thanks to lines 1 and 2, the function hello will absolutely exist when I'm ready to use it on line 6. So let me go down to my terminal window and run python of hello.py, enter. Here comes my name again. And now, when I hit enter, I now see hello, David. All right, we've kind of regressed though, right? This is not nearly as pretty as it once was. I think we can probably do better than this by improving things further. Why don't we consider, though, how we might, say, parameterize this same function? That is to say, can we customize hello to maybe take the user's name as input so that we can say not only hello, but the person's name all on one line, all in one breath? Well, I think we can do this. Let me propose that we do this as follows. Let me go ahead and up in my code, let me, inside of these parentheses, let me come up with my own parameter name. I have complete choice here. And I'm going to say that the name of my parameter will be the word to. Why? Because I want my function to sound like the verb it represents, hello. But who do you want to say hello to? Well, I'm going to call my parameter for this function to, just because in English it kind of sounds nice to me. Hello to. Who do you want to say hello to? That's why I'm calling this parameter to instead of something simpler like x or y or z. All right, well, what do I want to do with the word to? Well, I can do a couple of different things. We've seen like so many different ways to implement hello. Let me just add a comma there for grammar's sake. And then let me put the word to after that as the second argument to the function hello. There's other ways we can do this, and we've seen so many, but this one looks a little clear to me, I'll say. What's going to happen next? Well, I don't think I need this extra print line here. I think what I'm going to do is this. I'm going to go ahead here and print out not the person's name manually. I'm going to instead say hello parentheses name. So what am I now doing? On lines 1 and 2, I'm defining my very own function called hello. But this time, that function has been designed to take a parameter, a single parameter, as input. And I'm using the value of that parameter, which I called to plug into print so that I see not only hello, but also that person's name. What am I doing on line 5? Same as always. I'm just getting the user's name. Line 6, I'm not only calling hello, I'm passing as input the name variable as an argument so that that's what gets passed into hello. And what's happening here is essentially this. Even though the variable is called name here, when the function itself is called, the computer assumes that that same value is now called to. So name is essentially copied to another variable called to, so that in the context of hello, I can say hello to that variable instead. And we'll see in a moment what happens if we don't keep those straight. Let me go ahead and run Python of hello.py, enter. What's your name? And now I'm crossing my fingers, enter. There we go. We're back in business. But now I have my own custom function called hello that's allowing me to say hello to a specific person. And here's where now things can get really fancy. What if you wanted your hello function to say hello to someone specific, but you know what? If you don't know who you want to say hello to, you want to say hello to the whole world, you can give parameters default values. We've seen that. Recall that with print, there was a default value for sep, for the separator. There was a default value for end, the line ending. We can do that too. And here's the syntax. If you want the value of this parameter by default, if not provided by the programmer, to be equal to quote unquote world, you literally do that in the same line you're defining the function. And I'll admit it's starting to look more cryptic, but I'm still just defining a function called hello. It takes a parameter called to, but I'm assigning it with the equal sign a default value of quote unquote world, just in case the programmer doesn't call hello with an argument. And we can see this here. Let me change my code to use hello in two ways. On line 5, I'm going to very simply call hello, no arguments. Then on line 6, I'm going to get the name. Line 7, I'm going to call hello with an argument. So you'll see hello now being used in two ways. Let me go ahead and run Python of hello.py. I'll type in my name. Oh, interesting. Notice I already see hello world, but that's expected because line 5 happens before line 6. But once I type my name, now the program's going to be a little more polite and say hello to me personally. So there too, we see with relatively simple but new syntax how you can implement functionality very similar in spirit to what the print function gave us automatically. Now you have control over doing that yourself. But let me now make this point too. One of the whole points of defining your own functions is, one, just to avoid having to repeat yourself again and again. You don't have to actually keep reinventing the wheel and keep using the print function again and again and again if you just want to say hello. Wouldn't it be nice now if I could kind of move this code that I wrote for defining the hello function, and just to be dramatic, I'm going to hit enter a whole lot of times, 50 lines down, and put my definition of hello way further down in this file. Why? Well, just in the spirit of out of sight, out of mind. Because if I now rewind to the start of my program, now you can sort of take for granted that, oh, hello is a function. Why? Because it's there on line 1, and it has an open parenthesis and a closed parenthesis, which up until now has meant call this function. And then on line 2, we're getting a variable from the user by typing in their name, and then we're calling hello, passing in that value. Well, at this point, I can just take for granted that hello exists, even if it's way down further in the file, or as we'll see in future weeks, even if it's in a different file altogether. But there's a problem here. And let me go ahead and run this version of hello.py. Notice that as soon as I run the interpreter, Python of hello.py, I see a name error. Name hello is not defined. Again, did you mean help? Well, again, fitting. I do need some help here, but I didn't mean to call the function help. The problem here, though, is that Python is just taking me literally. I have defined my function hello all the way down here, but I'm trying to use it way up here, and that's not allowed. Python's interpreter is going to take you literally, and if you use a function, it must already exist by the time you are calling it. So how do I fix this? Well, apparently I can't do that. I have to define any functions I want at the very top of my file. But that too could get me into a bit of trouble eventually, because if I constantly have to define a function above where I want to use it, you're kind of writing code in reverse. You're constantly writing functions up here, up here, up here, as opposed to like writing your code logically top to bottom. So let me fix this in a more standard way, which is to do this. Generally speaking, you do want to put the main part of your code at the top of your file. And in fact, I'm going to go so far as to define my function called main. It's not a requirement, but it's indeed a convention. And this just connotes to the reader that this is the main part of my program. I'm going to get rid of my empty hello call now and only pass in one version with hello name. And then down here, a couple lines further down, I'll actually define my hello function. Unfortunately, now that I've reordered the functions in this way, by putting the main part of my code at the top and hello at the bottom so that my logic kind of flows top to bottom, if I go ahead and run Python of hello.py, enter, nothing whatsoever happens. If I do it again, nothing whatsoever happens. Well, why in the world is this? Well, just because I've defined a function called main and I've defined a function called hello doesn't mean that I've actually called, that is, used either of them. Yes, I'm using hello inside of main, but no one is telling Python to actually use or call main. So in order to tidy this up, the last thing I need to do in this file, it seems, is actually call my main function. And in fact, by calling my main function in this way, it gets me out of trouble because now I'm defining main first, but I'm not calling hello yet. I'm defining hello next, but I'm not calling hello next. I only, at the very end of this file, call main, which has the effect of running this code up here, which has the effect of running this code down here, and it allows me, therefore, to organize my file and order my functions in any way I want, including main at the very top, and solving, ultimately, that problem of Python not knowing what's going on. Now, it's important to note that I defined my function hello as taking an argument 2, and then I passed into that function the value of the variable that I wanted to say hello to, that is the variable called name. Because suppose I had done something a little bit differently. Suppose that I hadn't defined hello as taking an argument, so I just remove mention of 2 and its default value world, and I go back up to my main function and I just call hello itself without passing in any arguments. And now let me go ahead and make one more change, one more mistake technically. Let me go ahead and just try to naively print out the value of name in the hello function. So now to be clear, in my main function on line 2, I'm defining my variable called name and assigning it the return value of the input function from the user. I'm then just calling hello. In my hello function, which now no longer takes any arguments, I am calling print, passing in hello, comma, and then immediately passing in name, the variable into which I got the user's input. But the catch is that name exists now only in main. And so watch what happens when I try to run this version of the program with Python hello.py. I hit enter. I'm prompted for my name, D-A-V-I-D, enter, and a name error. Name, quote unquote, is not defined. So it turns out that this is actually an issue of what's called scope. Scope refers to a variable only existing in the context in which you defined it. So insofar as I define this variable name in my main function, I can only use that variable in my name function. I can't use it, as I've tried to here in my hello function. It doesn't exist in that so-called scope. And so this is why now, if I rewind and undo all of those changes, you'll see that I'm deliberately passing main from my main function into my hello function. And now in the hello function, it technically has a different name. It's called to in that context, but that's fine. It's completely up to each individual function to name its own variables or name its own arguments. But this is a way now that I'm handing to the hello function the value of that variable so it can be printed by hello as well. And there's one final flourish we can add here. Now that we've implemented hello, you'll notice that hello only has a so-called side effect. It only prints out something to the screen. Well, what if I also want my function to not have a side effect per se, but actually hand me back a value? Recall that the input function returns a value, the string that the user typed in. Recall that the int function returns a value. The float function returns a value that was passed into it. Well, you can use one final keyword here, literally return, to return a value explicitly yourself. In fact, let me go back to VS Code here, and I think we'll return our attention to calculator.py and see if we can't implement one other version of calculator.py that actually has our own function that even returns a value. So I'm going to go ahead and open up calculator.py, and I think this time I'm going to throw everything away as before, and I'm just going to start practicing what we're preaching here. Define a function called main, which is now going to be the main part of my function. Let's go ahead and now declare a variable called x and assign it to the converted version of the user's input after asking them what's x. So again, a line of code quite like we've done before. And suppose now that what I want to do is square this value. I want to take the number that the user's typed in and raise it to the power of 2. So 2 squared would be 4. 3 squared would be 9. 4 squared would be 16, and so forth. Well, how do I go about implementing a function literally called square, which actually doesn't come with Python built in? Well, let me assume for the moment that it does exist, and let me say something like this. Let me go ahead and say that printing, how about x squared is comma square of x. So what have I done? I've defined a function called main, and I've implemented 2 lines. The first of these lines prompts the user for a value x and converts it to an int and stores it in a variable called x. On line 3, I then say x squared is, and then I pass a second argument to the print function, whatever the return value is of a square function. But square doesn't exist, and I'll show you this here. If I now call main at the bottom, and I run Python of calculator.py, I'll see that x is 2, and then I see a whole bunch of errors. A name error, name square is not defined. So this isn't a typo here, it's just the function doesn't exist, but I think I can make it exist here. Let me go ahead and define another function called square. This one's going to take in a number, and I'm going to call it generically n, as many a programmer would, just to represent any old number. And then what do I want to do in order to square n? Well, a number squared is really just itself times itself, so I'm going to do this, n times n. But it's not enough just to do the math yourself, n times n. You're going to have to return the actual value, n times n, and that's our new keyword here. When I now do this, watch what happens. Python of calculator.py, enter, x say shall be 2, x squared is 4. Let me go ahead now and say x is now 3, x squared is now 9. So I've implemented my very own function that returns the square of a value, and because I'm using the return keyword, that ensures that I can pass the return value of this, just like the return value of input or int or float, to another function, like print instead. And here too, there's going to be so many ways to solve this same problem. I can actually raise n to the power of 2. We've not seen the syntax before, but if you use 2 asterisks like this, 2 stars, that raises the thing on the left to the power on the right. Or it turns out there is in Python a function called pow for raising something to the power that takes 2 arguments, the first of which is the number, the second of which is the exponent. So there too, there's just so many ways to actually solve that same problem as well. So ultimately, what have we done here? We first introduced functions. These actions are verbs, many of which come built into Python that you can just use in your own code. We then introduced variables via which you could store those return values and then maybe do something more with it. At the end of the day, too, you now have the ability to create, to invent your own functions to solve simple problems like hello, or in the weeks to come, much more sophisticated, more challenging, more fun problems as well. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is an introduction to Visual Studio Code for CS50. Visual Studio Code, or VS Code, is a very popular program nowadays for writing code. It's technically a text editor, or nowadays really an IDE, an integrated development environment, which means it's a program that's designed for enabling you efficiently and effectively to write code in your computer. Now, it turns out you typically install VS Code on your own Mac or PC. It's free open source software, which means anyone can download it on their own computer. But typically when installing it on your own computer, particularly to use for programming with a language like Python, there's a few other steps as well. You need to install support for Python itself. You might need to configure some of the lower level implementation details of your computer just so that things work. And so instead for this course, we recommend that you use VS Code, yes, but you use it in the cloud by way of CS50's own implementation thereof on top of something called GitHub Codespaces, which is a hosted version of the same. To use Visual Studio Code for CS50, go to code.cs50.io, where you'll be prompted to log in with your free github.com account. After some number of seconds or minutes, you'll then be redirected to your so-called code space, which is your own virtual space in the cloud. Somewhere out there on GitHub servers, you will have access to your own storage space, really your own hard drive in the cloud, in which you can create files, run programs, and even organize everything in folders. You'll also have the ability to write code via that interface and much more. The interface you'll see typically looks a little something like this, whereby you'll have at the top left hand of your screen a file explorer that allows you to see all of the files you've created over time in your account. You'll then have the ability at the top to actually write code by creating one or more tabs in which to write your programs. And then perhaps less familiarly, at the bottom of the screen, you're going to have access to what's called a terminal window. A terminal window is a command line interface, or CLI, which is very much in contrast with what you and I are mostly familiar with nowadays, which is a graphical user interface, or GUI. Indeed, everything we're seeing here is graphical by nature. There's buttons and icons and windows and more. But underneath the hood, you actually have access not only to your own virtual hard drive in the cloud, but actually your own server too. Somewhere out there on GitHub servers is your own server in a sense, your own virtual server, or technically called a container, in which all of your own files will live. You then have the ability to create files, run programs, even install additional software within that server or that container, because that server container is itself running its own operating system. And the operating system it's running is not Mac OS or Windows, with which you're probably familiar, but another popular operating system called Linux. And Linux is used by so many programmers and more nowadays, not only to write code, but to run it on their own servers as well. So how can you go about leveraging this new command line interface? Well, it's worth learning just a few commands that you might not have typed previously. These commands work not only in Linux, but also on Mac OS, and also with some modification potentially on Windows as well. But if you're using Visual Studio Code for CS50 in the cloud at code.cs50.io, you'll have the ability to run all these commands and more. And here is just a few of those that you can type. I'm going to go ahead now and type code, which actually is a command that comes with VS Code itself that enables me to create new files and open new tabs. I'm going to change screens over to my own computer here, in which I have full screen VS Code for CS50. So this is my browser window, full screened, connected to my own code space, my virtual container in the cloud. And suppose that I want to go ahead and create my own first program called hello.py, a program written in Python. In my terminal window, I could type code hello.py and hit enter. But before I do, notice at top left in my so-called file explorer, there's technically nothing there. There's some mention of code spaces and some mention of my own unique ID, but there's no actual files or folders there yet. But when I hit enter, thereby creating a new file called hello.py, I'm not only going to see it appear in just a moment in a tab where I can edit it, I'm also going to see a graphical representation of it up here, which is only to say that this environment, this integrated environment, all works cohesively. Here we go, hitting enter. My tab has opened. My prompt is blinking here so I can start writing code. But you'll also see that hello.py not only exists, but is highlighted as the file I've opened. Well, let me go ahead and write a very simple program now. Print, quote unquote, in parentheses, hello, comma, world, which, as you'll see, if not already, is perhaps the most formative, most canonical program you can write first when writing code in most any language. I'm going to go ahead now, and in my terminal window, I'm going to run one other command that you'll learn all the more about soon too. I'm going to run Python itself, which is not only a language, it's actually a program that understands that language. And if I specify not just Python, but a space, and the name of a file that I have created containing code written in that language, crossing my fingers as always and hit enter, I've just run my own program. Now on our Macs and PCs, we're generally in the habit of like pointing and double clicking on icons, or on our phones tapping on icons to launch some file or program. In a command line interface, or CLI, everything is done with the keyboard. You can use your mouse to move your cursor up and down as needed, but generally you do everything with your keyboard, not really with your mouse. Everything else on the screen can be clicked on, but in your terminal window, you'll generally see this prompt. A single $sign that does not mean dollar or currency for that matter. It's just a standard symbol that means type your commands here. And it's a visual indicator that you can type your next command. And indeed, the two commands I've thus typed are code to create my new file within VS Code itself, and then Python, which we, CS50, already pre-installed into your code space so that you have built-in support from day one with writing your own code. Now, there's other things I can do in this environment. I, for instance, could control click or right click up here and see a whole menu of options with which to edit or modify that file, just like on Mac OS or Windows. I could click on some of these icons at top left, the plus icon to create a new file or a new folder. So all of those GUI conventions, graphical user interface conventions, are still there, but you will and should get more comfortable over time with the command line interface alone, which does all of those things and more for you. In fact, here are just a few more of the commands that you can use within Linux and this command line interface specifically. We'll see in a moment ls, which allows you to list all of the files in your current folder. cp, which will allow you to copy a file from one place to another. mv, which will allow you to move a file or really rename it from one name to another. rm for remove, which will allow you to delete a file. Makedir, or mkdir, which will allow you to make a directory, that is a folder. cd, which will allow you to change directories from one folder to another. rmdir, which will allow you to remove a directory, and then clear, which will just aesthetically clear your terminal window if, like me, you like to keep things a little bit tidy. Now, these are just some of the commands you can type within Linux at this command line, but they're really equivalent to all the kinds of things you and I already do frequently on our own Macs or PCs. Let me go back to VS Code here, and let's just try out a few of these here. I'm going to go ahead and first clear my screen as though we're starting from scratch, but this doesn't change or delete any of my files. It just clears my terminal window. I can alternatively hit Control-L to do the exact same. Now I'm going to go ahead and type ls, but before I hit enter, note that ls kind of sounds like list. And indeed, this command and almost all of those others were fairly succinct in that ls means list, but you only type the L and the S, no list. And this is true of a lot of command line interface commands. Just to enable you and I to type things more quickly, a lot of these commands have these, this very succinct syntax and names. So here we go. I've typed out ls already. I'm going to go ahead and hit enter. And you'll see only one thing, hello.py, which is to say when I try to list all of the files in my current default folder that just automatically opens when I launch VS Code in the cloud, I only see the one file exists, which I can also see graphically here. Well, let me go ahead now and do something else. Let's make a copy of this file and call it goodbye.py, just so in anticipation of writing a second program that says goodbye world instead of hello. I'm going to do cp for copy, then the first name of the file, hello.py, then a space, and then the new name for the new file, goodbye.py, enter. And now notice nothing really has happened, and that's generally a good thing. If you don't see an error message down here, you've done well. But you do see graphically up here that both files now exist. Now I could open goodbye.py in a couple of ways. I could actually just go up here and double click on goodbye.py to open it here, or I can type the same command as earlier, code of goodbye.py, and now I'll have a second tab open here. And for parallelism, I could change this word from hello to goodbye, just so I have a second program now that is indeed the second file as well. Now, what if I decide that I don't want this file, and I'm going to go ahead and close it here, and I want to rename it and change it to from goodbye.py to farewell.py? Well, it still says goodbye.py up here. And if I type ls down here, I'll see a list of two files now that are in that same folder. Let me do mv for move, goodbye.py, and then something like farewell.py instead, enter. And you'll see that it changed up here at left. And if I type ls again, you'll see that it changed down here as well. Well, you know what? Let's never mind with farewell.py. Let's go ahead and just remove this file altogether. I could go up here and single click on farewell.py in my File Explorer, control click or right click, and then select delete. Or down here in my command line interface, I could do this. I could do rm space farewell. And now notice, if I'm a little tired of typing out these long file names, Linux and command line interfaces frequently support autocomplete. So instead of typing farewell, I'm going to type FAR, which sounds like more than enough characters to finish the rest of my thought. And I'm going to hit tab on my keyboard, and it just finishes it for me without having to manually type the same. I'm going to go ahead and hit enter, and I'll see a somewhat cryptic message now, as many of them admittedly are. It's not an error, it's just a prompt. Remove regular file, quote unquote, farewell.py. This is just a safety check to make sure that I'm OK with deleting this file. Generally, when prompted with a question like this, go ahead and type in Y for yes or N for no, and hit enter. And now nothing bad seems to have happened in terms of any messages, but indeed, farewell.py is now gone. Well, what more can we now do? Let me clear up the screen just for aesthetic's sake here, and let's create one or more folders, not just files. Let me go ahead and make a directory here with make_dir, and let me just call it folder, though I could call it anything I want. Alternatively, I could go up here to my File Explorer, click on the plus icon here on the folder, and manually create a no folder as well. But here again, the goal is to focus on this command line interface instead. All right, make dir folder and hit enter. Nothing seems to happen in the way of error messages, but now notice there's not just hello.py, but a folder or directory called folder. Well, what now can I do with that? Well, let me go ahead and see what's inside. Well, in my GUI, my graphical user interface, I could click on the folder here in this little triangle and look inside. And of course, there's nothing there because I literally just created it. But let me do this now in my terminal window. Let me type ls after clicking down here, and we'll see both my folder, which by convention has a slash at the end to make visually clear that it's a folder, not a file, and there's hello.py. Let me go ahead now and change directory. Now, on Mac OS or Windows, we would again just click or double click on the folder and see what's inside. In a command line interface, you need to be more deliberate. cd space folder, with or without the slash is fine, and then hit enter. And now you'll see that your prompt changed. There's still a $sign, but by convention, and this is a CS50 detail, though other people do this too in the world, we have prefixed your prompt with a just quick reminder of what folder you're in so that you don't forget whether you're in your main folder where you began or some other folder therein. I'm going to go ahead now and type ls to list the contents of this folder. And of course, there's nothing there because I haven't created any files. But if I do this, I could do code of farewell.py again to bring it back, but this time in this folder. Hitting enter, you'll see a new tab opens here where I can write some more code. But you'll also see hierarchically here that farewell.py is now inside of this folder. Now, suppose this is a mistake and I didn't mean to do that. What can I do? Well, let me close the tab here, even without writing any code. And down in my terminal window, let me do this. I'm going to type ls to confirm that, yep, farewell.py exists there. But suppose I want to move it into my main folder. Well, like on Mac OS or Windows, I could click on the file here, farewell.py, and just kind of drag it up or down to put it where I want. But let's move it. Not rename it this time, but move it using that same mv command instead. I want to move farewell.py to the parent folder. In the world of files and folders, you can think of things like a family tree. And if you want to go up hierarchically, you want to go into the parent folder, so to speak, whereas folder is conversely a child of the default folder in which we began. So I want to move farewell higher up. How do I express that? Well, another piece of syntax in a command line interface is typically this, ... is a symbolic representation of whatever the parent directory is, no matter what its name is. In this case, it's my own default folder. Doesn't even matter what its name technically is. It's not pictured on the screen. I'm going to go ahead and hit enter and watch what happens at top left in the graphical version of the same. We should see that farewell.py now pops out of the folder, and the indentation changed to imply that it's not inside of the folder now. It's alongside hello.py. Indeed, if I close the folder here, I don't see a difference because there's nothing in there as well. Let me type ls to confirm in my terminal window. There's nothing in folder. Let me now go back to my parent directory. And I can do this in different ways. And like with programming itself, there's going to be many ways sometimes that you can navigate a command line interface. Here's one. I can do cd for change directory, and then space ... to go back to the parent directory. But another technique, especially if you're a little less comfortable with this whole new world, is whenever in doubt, if you want to go back to your default directory in which you began when you logged in, just type cd with nothing after it and hit enter, and you'll be whisked away back to the starting point. Indeed, if I type ls now, I'll see farewell.py, my folder, if empty, and hello.py as well. Now, I don't really need this folder because there's nothing in it anymore, so let's go ahead and delete that. I could click on it with Control-click or right-click in the File Explorer, and I could delete it manually like in Mac OS or Windows, or I can use my newfound commands, rmdir for remove directory, space folder, with or without the slash, and hit enter. And because it's empty, I'm not even prompted, it just goes away quite cleanly. And a final technique that you'll find quite helpful in the context of a command line interface is that it tends to store your whole history of commands. In fact, not just autocomplete, but if I hit up and up and up and up, you'll see my history of all previous commands scrolling up on there on the screen, which is helpful if I just want to execute one of them again. I don't need to manually type it out. I can scroll up and down and find the one that I want. So this then is just a scratching of the surface of a command line interface in the context of Visual Studio Code in the cloud. Most of these commands would be the same whether on your Mac or PC, at least if you're using a terminal window that's connected to a computer running Linux, be it a container or virtual machine or an actual server somewhere in the cloud. In the weeks to come for this class, will you have access to code.cs50.io and in turn your own code space so that you have access 24/7, 365 via a browser alone, so long as you have internet access without needing to install anything on your own Mac or PC. Toward the end of the semester, if you're feeling more comfortable and would like to use this same software, VS Code, if not Linux as well, you'll be able to also install those for free on your own Mac or PC and continue programming onward even after the course's own end. This then was Visual Studio Code for CS50, and with it, a command line interface. And this is CS50 itself. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code or this line of code or this other line of code instead? They allow you to take the proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly, mathematical questions, but we'll start there if only to keep the example simple early on. This first symbol, as you might know from math, represents greater than. The second symbol might not look too familiar because we usually write it all as one thing on a piece of paper. But on a keyboard, if you want to say greater than or equal to, you'd use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality. It represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or any others, we're going to need another keyword in Python. And that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py, the goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare in which we'll start to express some of this logic. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function and pass to the int function the return value of the input function, asking the user a question like, what's x? Question mark, as we've done in the past. Let's do this one more time with y, asking the user for the value of y, and again, converting that ultimately to an int as well. So at this moment in the story, we have two variables, x and y. each of which has values. And ideally, we should be able to now compare these values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print as much out. Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression named after a mathematician named Boole is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only 2 possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They are not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good I here. I don't want to assign y to x. If x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic. And more technically, it shows the program's control flow. That is, the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart. And you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape. And inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y. So of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this, and yet logically, I should know the answer to some of those later questions once I figure one out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this too is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, if x greater than y, if x equals y. So I'm going to implicitly, just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program. And I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program. And honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs. But it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what, even if I already figured out what I want to print on the screen, this new version of the program that has if, elif, might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here. But let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow down marked true. We print out, quote unquote, x is less than y. But then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say, the answer to the first question is now false, but the answer to the second question is now true. Because, of course, 2 is greater than 1. Well, let's go back to the diagram. Same as before. We start at the very top where it says start. the very first question up here now, x less than y, is an answer of false because no, 2 is not less than 1. So we follow this arrow to the next question, this diamond. Is x greater than y? Well, yes, 2 is greater than 1. So now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask one question, and boom, we're done. This time, we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code. And pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined. But logically, we shouldn't actually be getting there anyway, because it's got to be less than or greater than or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
A good question. And yes, so that's going to be my third and final approach. And if you don't mind, let's pivot there right away. Identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better. And that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, elif x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the two conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first two scenarios, logically, it's got to be the case that x must equal y if it wasn't the case that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here. And instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else, just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. It still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked one question or two, or worst case, 3 whole questions. But we can do better than that. Using else, as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here. And let's propose how we might ask a couple of questions at once this time. Perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine, is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use hopes else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. OK, x is not equal to y. Let's do it again. But 2 for x, 1 for y. X is not equal to y. And one third time, how about x is 1 and y is 1? X is now equal to y. Now, if we want to compare that visually to, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false. So we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture, just as we have lines of code. And then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that, too, I think is going to work exactly the same. But the picture now looks a little bit different. Notice that this was our flow chart earlier that represented that same logic. And there's a bit of complexity. You got to go left. You got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question. Is x not equal to y? And if so, true, we go ahead and print out x not equal to y? If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct. But now the diagram, instead of looking like this, is going to change the not equal to equal equal. And we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly. And one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here. And indeed, it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts. And that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file. And I'm going to go ahead and start by just getting the user's score, again, on some assignment or test or the like. And I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100 percentage points. Now, how could I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how might I express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grades range. If the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B, if it's in the 80s. If score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. If the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run Python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90. But I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score. And here, 70 is less than or equal to score. And then lastly, 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick. And this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score? And is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can in code in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further. And just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditionals, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I'd kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary. But yes, there's absolutely other ways to do it. But I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too, to just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before, this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark. And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10.
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers. But it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run Python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program. And I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark. And then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven. And I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true as its return value, I am going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist. And this program would break if I ran it right now. But that's OK. I have the ability, recall, to invent my own function. So let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n %2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of an infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n %2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and isEven, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more, what's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me, that I can now use in this program and, heck, maybe future programs that I write, I now have a function that no one gave me. I gave myself that I can use and reuse. And I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's OK because I know, because I wrote it, that that function isEven returns true or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class day before yesterday and today, sir. I have just one query, like basis on my background of Java. There, when we used to pass the arguments, we can also pass the address of the variables. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these is-evens?
So I actually had a question about defining a function, if that's okay.
Sure.
So if you define one, are you like within your code, like you made it up, are you allowed to use the dot operator like we did name.strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string. For the examples you gave, I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip. You can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems, and in the Python community of programmers, there tend to be some ways that are smiled upon more than others, and they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++ if you've programmed before. And if you've never programmed before, this too is going to be new. Instead of asking a question like this, if else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this. Return true if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. I mean, that's pretty darn close to something you might say logically in English, be it about even and odd or really anything else. So that program is going to work exactly the same. Python of parity.py, let me type in 2, it's still even. Let me type in 3, it's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0 or not? Like, that is by definition a Boolean expression. It has a yes/no answer, a true/false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct and still readable version of this code would be to delete this whole line, Pythonic though it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it doesn't, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement this same idea. Now, which is better? This is pretty darn good. And it's hard to take fault with this because it's so very succinct. But it's perfectly OK and just as correct to have an if and then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you've programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, ? And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter. Well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. If name equals, quote unquote, how about Draco Malfoy in the books. Let's go ahead and print out, quote unquote, Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who? ? Just to convey that we don't actually have a hard-coded response to that particular name. Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And voila, we see that Harry is indeed in Gryffindor. Let's run it one more time, Python of house.py. Let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter. And who? Because we haven't actually hard-coded with an if condition in this case what house Padma is meant to be in. All right, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these 2 blocks of ifs, leaving just Harry's for a moment. And let's use that or keyword again and say or name equals, quote unquote, Hermione, or name equals, quote unquote, Ron, thereby consolidating all 3 cases, if you will, into just one if statement. Then we still have a separate elif for Draco because he's not, in fact, in Gryffindor, and then the final else to catch anyone else. All right, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She, too, is still in Gryffindor. Let me try it with Ron. And that, too, still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You could imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you could imagine that code just getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py and let me propose that I get rid of my current if, else approach and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on. And then I'm going to go ahead and include a colon. And then underneath that, I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry. And I'm going to put Harry in quotes because it's a string or a stir. And I'm going to have another colon at the end of this line. And indented under that one, I'm going to go ahead and, for now, print out Gryffindor, which, of course, is Harry's house. Otherwise, I'm going to have another case for, quote unquote, Hermione. And similarly, I'm going to have under that indented print, quote unquote, Gryffindor, close quote. Now I'm going to have another case for Ron, also in quotes with a colon. Now print, quote unquote, Gryffindor. And now I'm going to have a other case for, let's say, Draco. This one gets a little more interesting because Draco, of course, now is in Slytherin. And then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window running python of house.py, enter, and let's go ahead and try Harry. And he seems still to be in Gryffindor. Let's run it again for Hermione, enter, Gryffindor. Let's skip ahead to Draco and type in Draco's name. He's indeed in Slytherin. Now let's try another name that we haven't handled a case for, like Padma again, enter. And we're just ignored. There's no output whatsoever because there wasn't a case for Padma. Now, we could, of course, go back in and explicitly add one for Padma. But what if we, similarly to the else construct, just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that, using this new match statement, is to still have another case, but then to use this single underscore character, which is used in other contexts in Python. But for here, it's meant to say whatever case has not yet been handled, go ahead and print out, as we did before, for instance, quote unquote, who, with a question mark at the end. Now let's go ahead and rerun this. Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now, I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all on the same line in the same if statement. But here we have now 3 case statements again for all 3 of those. Well, we can tighten this code up as well. But the syntax is going to be a little bit different. I'm going to go ahead and delete these 2 middle cases for Hermione and Ron. And then up here next to Harry's name, before the colon, I'm going to go ahead and use a single vertical bar and then a quote-unquote Hermione. Then another single bar and do quote-unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now one final run of the program with Python of house.py. Let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor. And indeed, all 3 of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably, it has tightened things up. Arguably, it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place. But ultimately, this would be an equally correct approach to that same problem. But it turns out with the match statement, you can do even more powerful forms of matching as well. Here, we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement, as has been peppered throughout. And you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding in some of these new keywords here, like if and elif and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it. And these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also these conditionals, but also next loops, the ability to do something now again and again. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on loops, this ability in Python and a lot of other programming languages to do something again and again, a cycle of sorts. And let's see if we can't begin by motivating exactly why we have this ability to do things cyclically using these loops. I'm going to go ahead here and open up VS Code. And in my terminal window, let's go ahead and create via code cat.py, a Python program that meows like a cat. And I'm going to go ahead here in this code tab. Very simply, perhaps, I'm going to start by implementing this cat just by using print. We're going to have this cat not make audible sounds, but just print meow, meow, meow on the screen 3 times. Well, I think the simplest way I can do this is just to print meow once, and to print meow again, and to print meow one last time on the screen. And now let me go down to my terminal window. Let me run python of cat.py, enter, and meow, meow, meow. All right, so this program works. This program indeed works if my goal is to get the cat to meow 3 times. And let me propose, just to help us wrap our minds around what's going on inside of the computer, let me propose that we consider this flowchart. So as before, we have this flowchart that starts with a this oval, which just means start reading here. And then notice it goes via arrows to a meow, 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 and then it stops. It's perfectly correct. And honestly, it's wonderfully simple. But I dare say we can find fault with my code nonetheless. Why is my code arguably poorly designed? Now, the answer is going to be loops in some way, but let's see if we can identify in what way the code is actually poorly designed in some sense. Let's see. Any thoughts, Alex?
Okay, so I mean, repeating the same action like 3 times or even more is not a good habit.
Yeah, I'm just repeating myself. And honestly, it's not that big a deal. If we go back to my code here, am I really doing such a bad thing by just printing meow, meow, meow 3 times? Not really, but let's consider the logical extension of this. Suppose I wanted to meow 4 times, or 5 times, or 50 times, or 500 times. Do you really think, even if you've never programmed before, is the solution to this problem really going to be to hit copy paste 50 times? Like, probably not. We can probably do better than that. And beyond it just being ugly at that point, having so many lines of identical code, just imagine if you wanted to change the code. Maybe I changed my mind and I don't want to make a cat, I want to make a dog. So now it has to say woof, woof, woof multiple times. Now I have to change that in like 50 different places. And yeah, sure, I could do find and replace, but come on. Like, we're programmers now. There's got to be a better way than just repeating ourselves. So I bet we can do better than that if we think about a little harder how we go about structuring this program. And we can do that if we augment our vocabulary just a little bit. It turns out in Python, and in other languages too, there's a keyword called while. And while is one way that we can express what's called a loop, a block of code that's going to do something again and again and again, 0 times, 1 time, 2 times, 50 times, as many times as we want. But while rather leaves to us the particulars of how we express ourselves to do something again and again. So let me go back over to VS Code here, and let me propose that I do this. While is a construct that allows me to ask a question again and again. And anytime we've seen a question, it's been in the form of a Boolean expression, a question to which the answer is true or false. Well, how could I do this? How could I print out meow 3 times and ask 3 times a question to which the answer is true or false? Well, what if I did some counting, right? Like literally on my fingers. And if I'm trying to count maybe down from 3, I want to meow 3 times. I can put 3 fingers up and I can meow. And then I can put like one of the fingers down and then meow. And I can put one of the fingers down and I can meow, put one of the fingers down. And maybe the question I can ask every time I meow is, do I have any fingers up still? Do I have any fingers up still? Do I have any fingers up still? And if the answer is true, keep going. If the answer is false, stop. So how can I translate that to code? Well, once we've added this while keyword, I think we have all of the building blocks already. Let me propose that I do this. Let me propose that I give myself a variable. And I'll call it I for integer, but I could call it anything I want. And I'm going to initialize it to 3. Then I'm going to use this new feature of Python, while, and I'm going to ask a question, the answer to which must be true or false. And I'm going to say, while I does not equal 0. So I'm going to ask the question, while I does not equal 0, do the following. Notice the colon at the end of the line. Notice my indentation. And just like with functions, just like with conditionals, you indent the lines that you only want to execute as part of this other thing. What do I want to do while I does not equal 0? Well, I think I just want to meow. But it's not enough just to write this code. If I were to very dangerously run Python of cat.py and hit enter right now, what might happen on the screen, whether you've programmed before or not? Why is this a very bad thing potentially? It's not going to break things, but it might lose control of my computer somehow. Any thoughts? Yeah, Timo?
Hi, I think it's going to continue to print out mail since I is always equal to 3 and the while is always true.
Yeah, exactly. If I'm initializing I to 3, that is setting it equal to 3 on line 1, then I'm asking the question, while I does not equal 0, and that's going to be true. It does not equal 0. It obviously equals 3. Print meow. And the way a while loop works is that the Python interpreter just keeps going back and forth. It goes from line 1 to line 2, then to line 3, and then it goes back to line 2 to ask the question again. If the answer is still true, it goes to line 3. It then goes back to line 2. If the answer is still true, it goes back to line 3. And to Timu's point, if you're never actually changing the value of I, it's always 3, you're just going to be looping literally forever. And this is an accidental infinite loop. So we've got to be smarter than that. And I'm not going to hit enter because I don't want to lose control over my computer here such that it's printing out meow forever. Fortunately, if you ever do that and you find yourself in an accidental infinite loop, Control-C for cancel or interrupt is going to be your friend. If you ever seem to lose control, you don't need to like reboot or turn off the computer. You can just hit Control-C in your terminal window, and that will likely fix it. All right, well, what do I want to do then after meowing each time? I think what I'd like to do here is maybe something like this. Let me update I to equal whatever the current value is minus 1 here. Whoops, sorry, minus 1. So if I, on each iteration, am updating I to be 1 less, 1 less, 1 less, it should eventually hit 0, at which point the answer to line 2's question will now be false. So let's see if this works. I'm going to go down to my terminal window and run python of cat.py, and I indeed get 3 meows. Why? Because I've kind of wired this up, kind of like a machine in software, if you will. I've set I equal to 3, then I keep asking this question. But I keep turning the gears. I keep changing the value of the variable to make sure that ultimately it is actually being decremented, that is, decreased by 1 until we eventually hit 0. Now, for those of you who think a little more graphically, let me pull up one of our usual flowcharts. This is just a representation graphically of the exact same thing. Notice what's happening. I first start the program, and then I initialize I to 3. And then I ask the first of my questions. Again, the diamonds always represent questions. And the answer is going to be true or false. Does I not equal 0? Well, it doesn't. It equals 3. So if I follow the true line, I meow. And then I follow this arrow, and I update I to equal I minus 1. At this point in the story, I presumably equals 2 mathematically. I follow the arrow, and there's the loop. This is why it's nice to see this graphically, perhaps, because you can literally see the loop back and forth. Now I ask the question again. Does 2 not equal 0? Well, it does not equal 0. It's 2, so we meow again. We change I from 2 to 1. Well, does 1 not equal 0? Well, obviously, 1 is not 0, so we meow again. We decrement I again. I is now 0. Does 0 not equal 0? No, it equals 0. So the answer is false, and we stop. So there, perhaps more so than any of our flowcharts before, do you really see the structure of what's happening inside of the program? And you don't have to get into the habit of making these charts or creating these charts, but just as a first pass at what's going on inside of the computer, that's indeed one way to visualize it instead. Well, let me propose that, like always, there's many different ways to solve this problem. And suppose you just like to think a little differently. Maybe you don't like starting at 3 and then counting down to 0. Why? Maybe your just brain doesn't work that way and you prefer to count up instead of down. Totally fine. Let me go ahead and change my code here to set I equal to 1 instead of 3. And here, let me just change my logic. Rather than checking for not equal to 0, like maybe you don't like thinking in terms of not because it's a little confusing, and it might be, let's just check that I is less than or equal to 3. So we'll be a little more explicit. We'll count from 1 up through 3, each time printing meow, but I'm going to need to change this line here. Let me see if we can't call on someone to change line 4 for me. How do I want to change line 4? To be consistent with counting from 1 up to and through 3.
I would be +1 every time you meow.
Yeah, exactly. In this case, we want to add 1, not subtract 1. And in fact, if you think about this, this too could end very poorly, right? If you start counting at 1 and you keep subtracting 1, subtracting 1, subtracting 1, I think we're going to find ourselves with the same problem, which is that we're never going to stop because we're going to keep getting more and more negative as opposed to ever getting up to the number 3. So I think you're right. I need to change this to be I equals I plus 1. And now notice, just for clarity too, the equal sign is, again, our assignment operator from right to left. Logically, this might otherwise strike you as strange. Like, how can I equal itself plus 1? Well, it doesn't until you execute this code from right to left. You add 1 to I, or you subtract 1 from I, and then you update the value of I on the left. The assignment copies the value from the right to the left. Well, how else might I do this? Well, I will say that most programmers, computer scientists more generally, tend to start counting from 0. It's a convention, and it actually has upsides even in Python and other languages where, generally speaking, it's a good thing to start counting from 0 instead of counting like we might in the real world from 1. Let's go ahead and adopt that convention now. Let me set I equal to 0, and I need to make a change now. Notice, if I don't change my logic, this program just became buggy. The cat has a bug. It's now meowing 4 times if I run it as is. But the easiest fix here would be to change my inequality to be this, less than, instead of less than or equal to. Now, I'm starting at 0, but I'm going up 2, but not through 3. And even though this might, of all the things we've seen thus far, seem maybe the least familiar, most of us might start at 1, 2, then 3. It's a good habit to get into now. Start at 0 and go up 2, but not through the value that you care about ultimately, 3 in this case here. Well, let me tighten things up a bit here. Not only will this now fix my counting problem, it now meows 3 times as expected, there's a more succinct way to express I equals I plus 1. And this is because it's such a popular thing to do in code. You can instead just say I plus equals 1. And that's it. You don't need to put everything on the right-hand side. This is a special syntax that says the exact same thing, increment I, but it does it with a fewer keystrokes. It's just a little more pleasant to type. It's a little faster to read. It's just a convention. Those of you who have programmed in C, C++, Python, not Python, C, C++, Java, JavaScript might have seen plus plus before or minus minus. Sorry, Python doesn't have it. So you cannot use that. This is as succinct as your line of code might get. All right, let me pause here to see then if there's any questions about these implementations of while loops.
Can we use stuff like for loops, which have a certain I value initialized to it at the start, and it runs from the particular condition you put into the thing and increment it as you go along?
Short answer, no. You cannot do what you're describing, but there is another type of for loop that we will soon see. But let's come to that in just a moment. Other questions on loops using while here?
So I had a question about the flowcharts.
Okay.
There were certain symbols for the certain kind of the statements. So are they certainly used for that kind of statement that they are put there?
They are. So I deliberately
use anyone.
I deliberately use certain types of symbols, certain shapes here, whereby an oval is conventional for start and stop. I used rectangles for any statement of code, like an assignment or a printing and so forth. And I used diamonds to represent questions that you might ask, conditions, as we've seen. If you're doing this for yourself, if you're just trying to make sense of your code and writing it down, you certainly don't need to use these formal symbols. But I tried to be consistent with some best practices. And in fact, let me come back to this same picture, because this was the first version of our picture, but we've since modified our code a couple of times. This, recall, was the version where the question we were asking was I not equal to 0. Let me go ahead and just change this code now to represent the next version we did, which, recall, changed our logic to start counting from 1. It changed our question to check is I less than or equal to 3. But then everything else was the same except for the counting, which is now plus instead of minus. And then we refined it a little bit further by counting now from 0 up to, but not through 3. And we tightened up this code here by just incrementing 1 by using the slightly more succinct syntax. So at this point, these flowcharts might become less and less useful for us because once you've wrapped your mind around the concept and hopefully the picture helps bring that concept to life, it's certainly fine to focus entirely on the code and only think about or even draw something like this if you need to wrap your mind around something more complicated than you're used to. Well, let me go ahead, if I may, and propose that we transition to another approach of types of loops using another keyword here, namely a for loop. And this is a word that does exist in other languages, but doesn't necessarily have as many features as other languages might use it for. But there is a different type of loop, not a while loop, but a for loop. And a for loop is going to allow us to express ourselves a little differently. But to do so, I'd propose that the easiest way is if we introduce one other idea in Python, which is that of a list. And here, too, no pun intended, we're adding to the list of data types that Python supports. We've seen strs or strings, ints or integers, floats or floating point values, bools or Boolean expressions. Python also has lists, which is another type of data. But wonderfully, this one's probably pretty familiar. A list of things in the real world is a list of things in Python. It's a way of containing multiple values all in the same place, all in the same variable. So what do I mean by this? Well, let me propose that we go back to our VS Code here, and let me kind of start fresh with my code here and not use a while loop at all, but let me use this new keyword for. The way the for loop works is that it allows you to iterate over a list of items. So what does this look like? It might look like this. For I in the following list of items, 0, 1, 2. This is my starting point, and on each iteration of this loop, that is, on each execution of this loop, again and again, I want to print out meow. Now, I'll admit, I kind of like the look of this code already, even though there's some new syntax here, because it's just shorter than the while loop, right? The while loop had multiple lines a moment ago, and it was entirely up to me to decide what I is. I have to check a condition. I have to increment or decrement I. Like I was doing a lot of work, relatively speaking, to make that thing turn, to make that loop go and go. It was very mechanical in a sense. You can kind of, in your mind's eye, maybe see the gears turning as all of these variables are changing and these questions are being asked. A for loop kind of simplifies all of that. And it just says if you want a variable, like I, a number, and you know in advance how many times you want this loop to execute, 3 times, we'll just kind of specify what it is you want I to take on as values explicitly. In this loop, I will be automatically initialized by Python to be 0. Then meow will be printed. Then Python will automatically update I to equal 1. Then meow will be printed. Then Python will automatically update I to be 2, and meow will be printed. And because that's it for the values in that list, Python will stop, and it will only meow a total of 3 times. What is the list? The list in this program is exactly that, 0, 1, 2, and notice the square brackets. Those aren't parentheses. Those are square brackets that represent a list. That's how you know visually as the programmer. That's how Python knows as the language that you intend for that to be a list. So let me go ahead and run this, Python of cat.py, and it works just the same. But it's only 2 lines. It's pretty readable once you have familiarity with that construct. But to my constant point about correctness not necessarily being the same as design, in what sense is this program perhaps poorly designed? It seems to work. It meows 3 times. But why might this not be the best way to solve this problem? Even if you've never programmed before, again, think about corner cases, things that may or may not happen. Think about extreme cases that really test the quality of this code.
Okay, I think that because like we are saying 0, 1, 2, which is 3 times. And then like if you want to print a million, you say 1, 2, 3.
Yeah, exactly. And that's what I mean about thinking about the extreme cases. If you're trying to decide for yourself if your own code is good or someone else's code is good, it might look so at first glance, but think about the extreme. Well, what if it's not 3 things? It's a million things. I mean, are you really going to write out 0 through a million, or 0 through 999,999. Like, no, you're not going to write that many numbers on the screen. There's got to be a better way. So let's do the better way from the get-go rather than set the stage for doing something poorly. And the one way we can solve this problem to improve the design is don't just manually specify the list of values. Use a function, someone else's function that comes with Python that gives you the list you want. And the easiest way to do that in Python is to use a function called range that returns to you a range of values. It expects as input at least one argument, and that number is going to be the number of values you want back. Those values are going to start at 0 and go to 1 to 2 and so forth, but they will go up to but not through the number you specify. So by specifying range 3, you're essentially being handed back 1, 2, 3 values. And by default, those values are 0, 1, and 2, and that's it. But what's brilliant about this is that now, to Hope's point, if I do want to meow a million times, I mean, that is an angry cat, I can now do a million by just typing a million. I don't have to literally type 0, 1, 2, 3, 4, all the way up to 999,999. I just do this. So that's got to be a better way long term. So that's indeed one improvement we can indeed make here, still using a for loop, but now using this range function. And just to show you something else that's Pythonic, this is not strictly necessary, but it's commonly done. There's a minor improvement we can make here, even if we're just meowing 3 times. And notice that even though I'm defining a variable I, I'm not ever using it. And it's kind of necessary logically, because Python presumably has to use something for counting, right? It has to know what it's iterating over. But there's this convention in Python where if you need a variable just because the programming feature requires it to do some kind of counting or automatic updating, but you, the human, don't care about its value, a Pythonic improvement here would be to name that variable a single underscore, just because. It's not required. It doesn't change the correctness of the program, but it signals to yourself later, it signals to colleagues or teachers that are looking at your code too, that yes, it's a variable, but you don't care about its name because you're not using it later. It's just necessary in order to use this feature, this loop in this case here. So just a minor improvement or change there. But to really get you intrigued by what's possible in Python, let's take this one step further. So if we really want to be Pythonic, this one, if you've programmed before, is kind of going to blow your mind, so to speak, whereby if I want the cat to meow 3 times, what if I actually do this? Print, open parenthesis, quote unquote, meow times 3. All right, you have to be kind of a geek to think this is cool, but this is kind of cool. So you can literally just print what you want, multiply it by the number of times that you want it, and you will get back exactly that result. Now, I've kind of made a mistake here, so let's see what this does. It's not quite as beautiful as this code might look to you, to some of you, to me. Let me run python of cat.py, enter. OK, it's a really like hungry cat or something. It's meowing really fast. But I can fix this, I bet. Let's think about now some of the basic building blocks we've discussed. The problem is clearly that literally meow, meow, meow is being repeated 3 times, but it's not as pretty as I want it. I want it to be meow, meow, meow on separate lines. What might be a possible solution here while still using this multiplication operator? And think back, we've used plus to concatenate strings. You can apparently use multiplication to concatenate strings, but more than once, again and again and again. How could I clean this up without reverting to my for loop or my while loop and still use multiplication in this way?
We can use the escape sequence, which should be \n.
Amazing. Yes, think back to \n, which is the way you as the programmer can express a new line in code. And I think if I take your advice, I put a \n there inside of my quotes so that at the end of every MEOW, there's a new line. Let's see how this looks. Let me clear my screen and run python of cat.py. OK, so close. I like this. Let me call on someone else. The only thing I don't like, and I know I'm being really nitpicky now, is that it's meow, meow, meow on separate lines, but there's kind of this extra blank line, which I'm just not loving aesthetically.
I think we can make end equal to colon, not \n.
Yeah, so here too, like all of these things we've seen in past weeks are kind of coming together, right? Recall that the print function lets you control what the line ending is. By default, it's \n itself, which is why at the very end of this print, the cursor is being moved again to the next line. Well, we need to just override that. So let me go into my code here. And let me change this to comma end equals quote unquote so that it's no longer the default \n. It's instead now going to be nothing whatsoever. That should eliminate then hopefully that additional blank line. So let me run this one last time here, python of cat.py, enter, and there we have it. So now, you know, at least as programming goes, it's kind of cool that I can distill this into a short line and express myself all at once. Now, to be fair, it's a little less readable. Like now I've got \n, I've got ×3, I've got end equals quote unquote. So you don't have to do things this way. My previous approach with a for loop, totally fine. My previous approach with a while loop, totally fine, and in some sense, perfectly well designed. But this is just yet another way to do it, but it's not a good thing if you or your teacher, your colleague, your friend are going to struggle to read your own code. But this is a feature of Python that some languages do not, in fact, have. All right, well, let me propose that things get more interesting still if we're not just meowing 3 times only, but we're meowing some variable number of times. Let's ask the user how many times this cat should meow. So let me clear the screen here, and let me figure out, well, how do I get a number from the user? The catch here is that if I want the user to give me a number, I'm not doing math per se, I'm meowing. And therefore, the user has to give me a positive value. The user has to give me a positive value. So how can I insist on this? Well, if I just do this, n equals int of input, what's n, question mark. Well, I want to check, like I could say if n is less than 0, like if it's negative, well, I could do this. Well, then ask again, int input what's n question mark. OK, well, what if the user still doesn't give me a positive number? What if they're being really difficult, they're not paying attention, and they typed in 2 negative numbers? Well, if n is less than 0, well, let's do it again. N equals, right, this does not end well. You can't infinitely many times keep checking, is it negative, is it negative, is it negative, right? The program would never be done written. So we can do this, I think, better maybe with a loop. So let me propose this, a very common paradigm in Python when you want to get user input that matches a certain expectation you have, that it's all positive, that it's all negative, or just something like that. You just immediately say while true. You deliberately, and a little dangerously, but very conventionally, induce an infinite loop. Now, what is an infinite loop? It's just one that goes forever. And we've seen how that can happen accidentally, mathematically. It's absolutely going to happen when you say while true. Why? Well, the answer to the true question is always true. So this is a way of deliberately inducing a loop that by default is going to go forever. So we're going to need a way of breaking out of this loop when we have the number we want. The convention, though, inside of this otherwise an infinite loop is to ask the question you care about, like give me an int by prompting the user for input, like what's n question mark, and then just ask your question. So if n is less than 0, then I think we want Python to just continue to prompt the user again. That is, we want the code to stay in the loop, recall the input function, and hope that the user gives us a better answer if this time around it's less than 0. So let's just literally use Python's keyword continue, which says just that, continue to stay within this loop. Else, if it's not less than 0, let's go ahead and just break out of the loop altogether using another keyword in Python, break. Break will break you out of the most recently begun loop. In this case, if it's not the case that n is less than 0. So this will work, and it will allow us to get a value that's 0 or greater from the user. But I think we can tighten it up further so as to not bother having an if and an else. Why don't we instead just say, if n is greater than 0, go ahead and break. In fact, it's not that interesting a program if we even allow the user to type in 0. So let's wait until they give us an integer that is greater than 0 and then break out of this loop. And what can I now do down here? For I in range of whatever that value n is, print meow. And honestly, I don't need I here, so let me come back to that principle before, and let me just change it to an underscore just to be Pythonic, if you will. So what's going on? Lines 1 through 4 deliberately implement an infinite loop that otherwise by default is going to go forever. But I'm asking a question inside of that loop. After getting an int from the user on line 2, I'm then checking, is it greater than 0? Or is it 0? Is it negative? None of which makes sense for a meowing cat. Like, I want the cat to meow at least one time. So if it is greater than 0, break. And this break statement, even though it's indented twice, has the effect of breaking out of the most recently begun while loop. So once the user gives you a positive value, then we get to line 6, at which point we meow that many times because of line 6 and 7. So if I run this now, Python of cat.py, enter, well, what's n? Let's start with 3, where we began. Meow, meow, meow. Well, this time, let me go ahead and increase the size of my terminal window just temporarily. Let me run Python of cat.py. Let me do it 10 times. Meow 10 times now appears on the screen. And the takeaways here are not just that we can meow 10 times or do something again and again, but this is a very common paradigm in Python when you want to do something again and again and again, but only until the user actually gives you a value that you care about here. And let me propose, actually, now that we practice a little more what we've been preaching, especially when it comes to, say, writing your own functions. Now that I'm doing all this meowing, it might be nice to actually have a meow function that the inventors of Python didn't envision. So let me do this. Let me actually get rid of all this code, and let me go ahead and do this. Let me go ahead and say define a main function, as I've done before, and let me just blindly call meow3. Meow doesn't exist yet, but when it does, that'll be great. So let me go ahead now and define meow. So my meow function should take as input a parameter called n, or anything I want. And this part's pretty easy now. How do you meow n times? Well, for underscore in the range of n, go ahead and just print meow. So same code as before, nothing new here. I'm just putting that logic inside of a meow function that's going to have this side effect of printing meow. And now, as before, let me go down here and let me make sure I call main. And if I now run this code, Python of cat.py, meow, meow, meow. It's always going to do 3 because I've hard-coded the 3. Well, let's make one improvement here. Let me go ahead now and maybe do this. Let me ask the user for a number. So let's say something like this. Number equals get number. All right, unfortunately, there is no function in Python called getNumber that gets a positive number from the user. But I can invent that. So define getNumber, open paren, close paren. And then inside of this function, let me do this. While true, go ahead and get a number from the user, converting it to an int, asking them what's n, question mark. And then if n is what I want, it's a greater than 0 value, a positive number. I don't want to break this time necessarily. Although I could, I instead want to return the value so I can actually do this instead. And this, too, is a feature of Python, this ability not to just break out of a block of code, but also to return a value in code. To actually return a value gives you the ability, ultimately, to return explicitly a value so that your function has not just a side effect necessarily, but it actually hands back, just like input does, just like int does, just like float does, an actual value to the user. Now, to be clear, I don't have to return n here. I can still break out of the loop, as I've done in the past with code like this. But then after the loop, I still have to return n. And so what's happening here is that if you use break to get out of the loop, but you need to hand back a value from a function, you still have to use the return keyword now explicitly, either in the loop as I did, or now outside of the loop, but still inside of the function. The last thing I'm going to do here now is change that 3, which we hard-coded earlier, to actually be the value of the variable we've gotten from the user, so that now down here, if I run Python of cat.py, enter, what's n? I can type in 3. I get my 3 meows. Or if I only want 1, I now get 1 meow instead. All right, so if we now have this ability to do things again and again in these loops, let's see if we can't solve some other problems via which to express ourselves cyclically, but get back some interesting answers as well. Let me propose, for instance, that we look a little more closely at these lists. It turns out that in Python, and really in programs in general, it's useful to have a list of values because we're going to be able to work with more and more data, larger and larger data sets. So let me propose that we come back to VS Code here, and let's do something that's perhaps a little familiar to some folks, the world of Hogwarts. And let me go ahead and code up a file called Hogwarts. And let's see if we can't have a list of students at Hogwarts here. So I have a new tab called hogwarts.py. And let me go ahead and propose that I just define in this program a list of students whose names I know in advance. So I'm not going to get user input for now. I'm just going to know from the get-go that the 3 students I want to consider are these. A variable is going to be called students. It's going to equal, as I've done in the past, a square bracket, which means, hey, here comes a list. And those values are going to be Hermione in quotes because it's a string, Harry in quotes because it's a string, and then Ron in quotes because it's a string as well. So this is a list of length 3. It's similar in spirit to my list of length 3 earlier, but that had 3 ints, 0, 1, 2. Now I have a list of 3 strings instead. And this isn't very useful at the moment, but let me just do something as a check for myself. Let me print out each of these students. Well, wait a minute. How do I print the contents of a list? Well, in the past, when we've printed a variable, we've just printed out the name of the variable. But I don't want to print out all of Hermione and Harry and Ron all at once. Maybe I want to print out Hermione first, then Harry, then Ron. So I need a way to express more precisely which value do I want from this list. And the way you do this in Python is you use square brackets in another way. If you have a variable, in this case called students, and you want to go inside of that variable and get a specific value, that is to say you want to index into the list, you use square brackets this way using numbers inside of the square brackets. And here's where we see that it is useful to think and count in terms of 0 on up instead of 1 on up. These lists in Python are, shall we say, 0 indexed. The first item in a list is at location 0. The second item in a Python list is at location 1, and the third is at location 2. So you're always kind of off by 1 mentally, but you get used to it if you've never programmed before over time. So let me print out all 3 students. So let me print out students bracket 0, then students bracket 1. Then lastly, let me print students bracket 2, and this is my third and final line. And of course, if I run this code, it probably does what you would guess. If I run python of hogwarts.py, there's Hermione, Harry, and Rob, each on their own lines there. But there's got to be a better way, right? Especially if I don't know in advance who's going to be in this list. If next year there's some new students at Hogwarts, we can use a loop to do something automatically without having to manually type out 0 and then 1 and 2. Well, here's another feature of Python. You can use a for loop, not just to count from 0 to 1 to 2. You can use Python to just iterate over anything, not just numbers, but strings. So I could actually do this. For student in students, colon, and then indented underneath that, I can say print student. Now, it doesn't matter if I have 3 students or 4 or 400. This 2 lines of code, this loop, will print all of those students for me one at a time. So if I now run python of hogwarts.py, there's the same list, but I don't need to know in advance how long that actual list is. Now, notice I made a conscious decision here. I didn't call this variable underscore, because this time I'm using the variable. And while I could do this, now, no. Your code is getting way too cryptic if you're naming the variable underscore and you're using the variable underscore. Now you're helping no one. Now you're confusing the reader yourself down the line. You should call your variables what they are. So a very appropriate name, though I'm sure you could come up with others, would be student. And here you would say student as well. If you'd prefer to be more succinct, it's not unreasonable to do something succinct in a loop like this. For s in students, using maybe the same letter that the list itself begins with. But again, why bother? Python is meant to be more readable. If you have a list of students, iterate over them 1 student at a time. Well, let me pause here to see if there's now questions about lists as I've now defined them, a list of strings in this case, or using a for loop now to iterate over and print each of those names.
Yeah, so is it not necessary to initiate student in this case, or we can just declare a variable in the loop?
Good question. You do not need to manually initialize it. Python takes care of initializing the student variable to Hermione first, then Harry second, then Ron third. Unlike other languages, you don't need to initialize it to something yourself. It just exists and it will work. Other questions on loops and lists in this way?
Since you described break, so is there any concept of continue so that we can skip a particular case in loops?
Yes, you can continue using another syntax as well. We haven't shown that. For now, we focused only on break.
Okay, sure. Can this for loop work with either hash tables or different kind of iterables or arrays?
Indeed. So we're getting ahead of ourselves there, but there are yet other types of data in Python. And indeed, you can use a for loop to iterate over those as well. Anything that is iterable, so to speak, is a piece of data that can be used with a loop like this. But more on those soon. In fact, let me transition here to show just another way of solving this same problem, because up until now, when we've used loops, we really have relied on numbers, and that's fine if you prefer to sort of stay in that space. Suppose I did want to iterate using numbers like I and 0, 1, 2, and so forth. Let me propose that we could change this code as follows. If you would prefer to think about, or if the program you're trying to implement requires that you use numbers like this, you might do this. For I in, well, I don't want to just say students, because then I is not going to be a number. I is going to be literally Hermione, then Harry, then Rob. I need to iterate from 0 to 1 to 2, right? If I know a list with 3 elements, has these locations, 0, 1, 2, I need to create a loop somehow that starts at 0 and ends at 2. Previously, when I wanted to do that, I needed range, but this 2 is not going to work. I can't just say in the range of students, because students is not a number. It's not an integer, so you can't pass it to range. Range expects an integer. But there is a solution here. It turns out that there is a function in Python called length, or len, L-E-N, that will tell you the length of a list and other things down the line too. And now I think I can assemble these building blocks in a way that can allow me to use numbers in this way. So range doesn't take a list of strings. It takes a number. And ideally, that number is going to be 3. So I get a range of values, 0, 1, and 2. So I think I can nest my functions like this. If I first get the length of the student's list, that's going to be 3. Then I pass that return value as the argument to range. That's going to give me back a range of values, 0, then 1, then 2. And what that's going to allow me to do then in code, if I want, is not just this. I could do print now students bracket I. And this is now where the syntax we're seeing is getting very expressive, new, and perhaps unfamiliar. But if I can do open bracket 0, close bracket, or open bracket 1, close bracket, or open bracket 2, close bracket, turns out I can actually put a variable in there. And I can express any number inside of those brackets so as to print these all out dynamically in a loop. Let me do this. Python of Hogwarts.py, enter. There's Hermione, Harry, and Ron. And now if I'm just curious, if I just want to poke around, or maybe I want to do a ranking, like who are the top 3 students in the school or in Gryffindor, well, I can print multiple things at a time, we've seen. Let me print out not just the students at location I, but rather let's print I first, and then the student at location I. So 2 things to print, and we know that print can take 2 arguments. We've seen that before. They'll be separated by a space. Let me go ahead and rerun this. Now I see that, OK, Hermione is the top student, but she's in 0th place. That's a little weird. Like, we don't need to show the human using my program that we started counting at 0. I can clean this up. I can just add 1 to the I up here. And now we see sort of a top 3 list of students. Hermione's number 1, Harry's number 2, and of course, Ron is number 3. So we can get access to all of those same values as well. All right, any questions now on these lists? Any questions now on these lists? This length, these ranges, or otherwise?
My question is, for I in range, can you explain this once more?
Sure.
Still looks cryptic.
So let me rewind in time. We started off doing this. For I in 0, 1, 2, and then we printed out meow 3 times in that way. The way that the for loop works is that it creates for you a variable that I've called I, but I could call it anything I want. It then assigns I initially to the first thing in the list. It then automatically assigns I to the next thing in the list. And then it assigns I to the third thing in the list. And each time, it does all of the indented code underneath. We realize, though, that this is not going to scale well if I want to do something like 1,000,000 times. So we introduced range instead. That has the effect of doing the same thing. It returns to me a range of values, a list of 3 things, really. So the behavior is exactly the same. If we now fast forward to this Hogwarts example now, though, what I'm doing is just combining these smaller ideas. I'm still creating a for loop. I'm still creating a variable called I. I want to do it over a range of values, but how many values? Well, if I use the length function, and pass to the length function the list of values, length's purpose in life is to tell me how long is this list, and it's 3. So that's almost as though before I had just done something like this, but I don't want to hard code 3. I want to dynamically figure out how many students are at Hogwarts. So I'm just composing, or nesting all of these various ideas. All right, if I may, let me transition now to in Hogwarts still to introduce one final type of data before we combine everything with a few final programs. It turns out in Python, there's not just strings, not just ints, not just floating point values, not just bools, not just lists. There are also what are called dictionaries, or dicts, which are a data structure that allows you to associate one value with another. Literally a dictionary, like in the human world, if you were to open a dictionary, be it in English or any other human language, what's inside of a dictionary? Well, it's a bunch of words and definitions. A computer scientist, though, and a programmer would describe those more generically as keys and values. Something associated with something else. That's all a dictionary is. It allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of two-dimensional, if you will. Just like a human dictionary, a book, it associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well, I could do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house. And let's add Draco in there. So we now have 4 instead of 3 students, just so we have a little variety. And he was in Slytherin. So now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Who's ever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want to keep track of more things than that? What if we want to keep track of every student's house and the Patronus, this image that they conjure up magically? Well, then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. A student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here. And let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings, completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students, and let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here, but notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea, a little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes, to get inside of them. So if you want to print out Hermione's house, the key you care about is quote unquote Hermione. And what this syntax here will do, notice it's not a number 0 or 1 or 2. It's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote unquote, Harry should give me Harry's house. Print students, open bracket, Ron. That should give me Ron's house. And then lastly, if I do this with students, bracket, Draco, that should give me Draco's house. Now, it's a little manual still. I bet we can improve this, but let me run Python on Hogwarts.py, and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now, all we've done, again, is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values respectively. Allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop. And this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So this is not going to be that interesting yet, but when I run Python of Hogwarts.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now, when I'm doing for student in students?
Yeah, I think we will only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses. But when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now. Enter. And indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. Can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary. Right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house. And the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do Python of Hogwarts.py, enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space comma. And just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not in fact Gryffindor, but that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does if I'm just correct me if I'm right, does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry and Ron as the indexes in the actual the list of students.
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable is called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2, it allows me to, for instance, set student equal initially to Hermione's name. And then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a Patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their Patronus in this case. Well, what might code like this look like? Well, let me go back to Hogwarts.py, and let me start fresh for just a moment, and let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students. And suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else. Well, here's one other way we can do this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, one dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that one key this time won't be the student's name explicitly. It will literally be the word name, and they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And this same student's going to have a third key called Patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Now I'm going to create a second dictionary inside of this list. And again, a dictionary is literally like the human dictionary of words. It's a book that contains keys and values, words and definitions. What are the 3 words I'm storing in each of my dictionaries? Name, house, and Patronus. What are the definitions of those words for Hermione? Hermione, Gryffindor, and otter, respectively. For Harry, the definitions are going to be different in this new dictionary. Let me give myself another pair of curly braces and say this. Name, quote unquote, colon, Harry. House here is again going to be Gryffindor. And this one I knew, his Patronus is going to be, in this case, a stag. All right, next, a third dictionary. The name here will be Ron. And I'm going to go ahead and do that just like this. Next, I have the house, and he too was Gryffindor. Lastly, had to look this one up, Ron's Patronus was a Jack Russell Terrier. Lastly is Draco in a 4th dictionary now, so another pair of curly braces. The name of this student is, of course, Draco. The house of this student is Slytherin. And Draco, interestingly enough, at least according to the internet, has no Patronus, was never revealed in the books or the movies. So it turns out, this is actually a wonderful teachable moment, There is a special keyword in Python that is literally none. N-O-N-E with the first letter capitalized. This represents officially the absence of a value. So I could a little sloppily do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no Patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. OK, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know that is a dictionary, a collection of key value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and Otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design. That's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students. And I can still do a loop. I can say for student and students, that's going to allow me to iterate over this list of students. And let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary, looking up the word name, and giving us Hermione, Harry, Ron, and Draco, respectively, from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione Gryffindor, Harry Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus, and then the values of those keys can actually be the data like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof?
I just was wondering if suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language. That is a feature of a dictionary to get you the data quickly. And there are functions that you can use. You can sort the data. You can sift through it. You can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up was this one here on the original Nintendo. And this is a two-dimensional world where the characters move up, down, and right, not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked on top of one another. And we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually using maybe just hashes for bricks. Because there's a pattern here, one on top of the other, and I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here. And let me propose that we create a program called mario.py using code in the terminal window. And then up here, let me start by implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run python mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe these the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned and instead do something like this. For underscore in range of 3, let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code 2, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can't now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse, they allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called printColumn. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, printColumn, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called printColumn. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run python of mario.py, we're back where we began. But I now have a function, an abstraction, printColumn, that's going to allow me to think about printing some chunk of the world of Mario at a time. And I can do this in different ways too. Notice that if I really want, I could do something like this. I could re-implement now printColumn in different ways, especially if I'm using printColumn all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my printColumn function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement printColumn, recall, would be something like this. A bit clever with one hash and then a new line. And then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's okay if you're not comfortable with this syntax. This was a more clever approach we saw in the past. But if I run Python of mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of print column has changed. Well, let's transition to a different dimension, if you will. And rather than print out just these vertical bricks, let's fast forward in the game to this part of the world here. At some part, Mario encounters these bricks in the sky that if he jumps up underneath, they become coins. And so he gains to his score. But let's go ahead and focus only on those coins. And let me propose that we print out, just these 4 question marks here. And let me go back to VS Code here. And let me propose that within VS Code here, just like before, we try to abstract this away. So let me go ahead and get rid of this version, because we're now going horizontal instead of vertical with our output. And let me just say, well, print row 4 times. Let me just abstract away the problem at hand. I don't know yet how I'm going to print those 4 question marks, but let's call it print row 4, and I'll assume I'll now solve this problem. Let's now go down that rabbit hole of solving the problem. Define a function called print row. It's going to take a width instead of a height, because it's horizontal instead of vertical. And how can I do this? Well, now we have an opportunity to do string multiplication even more elegantly. I can say quote unquote question mark times width. And this is a very pretty Pythonic way of printing what could otherwise be a loop, and that's fine. But this is going to go ahead and print those question marks for me. Let's do Python of mario.py, enter. And now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having print column and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this, or with the column version. But what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's 2-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3x3 grid, a 3x3 square of sorts. Well, how can we go about solving this here problem? Well, let me propose we come back to VS Code, and let me propose that we think about this in a couple of different ways. I could do this like this. If I know where I'm going, maybe I'm a seasoned programmer, let me go ahead and do this. Let me print out a square, the width and the height of which is 3. That's an abstraction. I'm just taking for granted for a moment that there is already a function called print square that's going to be width 3 and height 3 as well. But someone's got to implement this. And at the moment, there's only me at the keyboard. So let's go ahead and implement that square. Let me go ahead and define a function called print square that takes in a specific size, both for height and for width. And here's where we have an opportunity to use some of those loops. And we can use those loops in a way we haven't yet. If I want to print out all of these rows, but also all of these columns, I now have to think not just cyclically, like a loop allows, but I need to think 2-dimensionally. And if you're familiar with like an old school typewriter or even a printer nowadays, it generally prints from top to bottom. So even if you have multiple columns, you print out one line at a time. And while you're on that line, the printer or the typewriter prints from left to right. And that's kind of the mental model to have with your black and white terminal window. All of the output for every example thus far starts at the top and goes down to the bottom. From top to bottom, left to right. So we have to generate our output, our square, in that same way. So let me propose that we do this. Let me propose that we know we need to iterate this many times, 3 or more generally size. So let me do this. For I in the range of size, what do I need to do 3 times? Well, I want to print out what? 1, 2, 3 rows of bricks. But within each row of bricks, what do I want to print? 1, 2, 3 bricks specifically. So if we go back to our diagram here, and I stipulate that it's indeed meant to be a 3x3 square, 3 wide and 3 tall, what do I want to do to print the first row? I want to print brick, 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 brick. What do I want to print on the second row? Brick, brick, brick. And the third row, brick, brick, brick. So I'm doing 3 things 3 times. There's a lot of printing that must happen. So let me go back to my code here, and let me propose now that we think of this outer loop that I've just started as representing each of our rows. For I in range of size is going to ensure, no matter what I do next, that I can print out 1, 2, 3 rows, or more generally, size, where size could be 3, but it could be smaller or larger. What do I want to do on each of the rows? Well, just like an old school typewriter or printer, on each row, I want to print out brick, 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 brick. Well, that sounds like a cycle, some kind of loop. So maybe I can have inside of one loop another loop. I don't want to use I again because I don't want to use the same variable and mess up my counting. So I'm going to, by convention, use j. Very common to use I and then j, maybe k. But after that, you shouldn't keep nesting inside of each other. Let me go ahead and say for j in range of size 2, because it's a square, and then each of these rows, let me print out a single hash, but no new line. But after each row, let me print only a new line. So there's a lot going on here, especially if you've never touched Python, let alone loops. But notice what I've done here too, and I'll add some comments for clarity. For each row in square, for each brick in row, print brick. And here is where comments, and more generally pseudocode, can really help explain to yourself and to others what your lines of code are doing. On line 8, I'm iterating from I equals 0 on up to size, so 0, 1, 2. On line 11, I'm doing the exact same thing, but using j from 0, 1, 2. But that's good, because I represents now each of my rows. And while I'm on each of those rows inside of this outer loop, I'm going to do brick, brick, brick. 1, 2, 3, 1, 2, 3, 1, 2, 3. But I don't want my cursor to keep moving to the next line while I'm on a row, so I'm just overriding that line ending. But let me ask a question of the group now. Why on line 16 do I have a print here all by itself? Why do I have a print all by itself? Notice that it's below the inner loop, but inside of the outer loop, so to speak. What is that loop on line 16 doing ultimately?
Every time you finish a line, you have to add a new line at the end of it. So
Perfect.
it prints a new line.
Perfect. I don't want a new line after every brick. I only want to do that at the end of the row, and that's why my comments now are perhaps enlightening. Notice that this loop here is just iterating for each brick in the row. Once I'm done with that inner loop, so to speak, once I'm done with these highlighted lines here, to Evelyn's point, I need to print out one blank new line. And we've not done this before, but when you call print with no arguments, all you get is that automatic line ending, the \n, where the cursor moves to the next line. So if I now go back to my terminal window and run mario.py, I think I should get a 3 by 3 square. And it doesn't quite look like a square on my screen because these hashes are a little taller than they are wide, but it is in fact 3 by 3. But let me propose, as we've always done here, how we might tighten up this code further. Just for clarity's sake, let me get rid of my comments for a moment, just so we can see how many lines of code we have total. And let me propose that we maybe do this. Let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them? Right? We draw inspiration from an earlier approach, and we run Python now of mario.py, same result, but now print square is really nice and compact. It has one explicit loop, and it's still printing out using string multiplication all of the hashes at once on that row. If you like abstraction and you'd like to wrap your mind more around what the code is doing, well, let's do this. If you're not quite clear on what's going on, let's propose that you implement a function called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby, well, what does it mean to print a row? Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string multiplication trick. This is a way to take a larger program, and this is probably the most complicated one we've looked at thus far, and to decompose it into these smaller components that, once assembled, achieve your final idea. Seeing no questions, that's the end of our look at loops in Python, this ability to do things cyclically again and again. And when we combine those with conditionals, this ability to ask and answer questions and combine them with our functions and variables, we really now have most of the building blocks we need to solve much larger, much more interesting, much more personal questions. So in the weeks to come, we'll start to see exactly what could go wrong, though, when we do so. But we'll introduce you to all the more tools via which you can troubleshoot those same problems. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? So I'm going to go ahead and open up VS Code on my computer here. And in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world. And then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make. And it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter. And that's the first of my errors. My gosh, I've only written one line of code, and I seem to have more lines of errors on the screen. But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message, but unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we discussed before, or str in Python. And literal generally refers to something that you literally typed. It's not a variable. It's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running. And it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program. And so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer like x and then just prints out what x is. So we're going to start super simple. But again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input quote unquote, what's x question mark, and I'm going to include a space to move the cursor over a little bit. And then ultimately, I'm going to go ahead and, oh, wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out quote unquote x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well. I'm being prompted for x. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong, and in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not, in fact, an integer, I can't just blindly convert it to an int. If I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive, and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, python of number.py. Let me try another number. And in fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That, too, is pretty different in spirit from 50. -1? OK, that works, too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number. And yet, let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values. And it's a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this too is a bit of a mouthful. And unfortunately, in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem. For int, what is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer. Or please don't type cat. Please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that, too, is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try. And it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here. And let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case. And then I'm going to add one more new line down here that literally says except value error. And notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive. And this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work. And of course, I'm trying and succeeding. Let me go ahead and try once more, this time, though, with the word cat, or really anything that's not a decimal number. And now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, as a user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get, or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today. And there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come. But the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here, you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong. And if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer. So it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code. But in the interest of preaching best practices, you should really only be trying to do the one or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really, what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error. But I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run python of number.py, enter. Let me go ahead and do it correctly with 50. And all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in cat again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code, like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here. And it's telling me name, quote unquote, x is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago. And I'm defining x on line 2. But let me ask the group here, why does x not, in fact, exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
Maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, x exists once it's defined on line 2, because remember, I printed out x is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is x somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance. Global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine, because we've used that a lot now to get users' input. It always returns a string or a str in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error. But because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, else, and we're also using else with these try except blocks, but that's OK. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.py, let's do something correct like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line 2 is executed because the conversion happened successfully and the number 50 gets copied from right to left. The exception does not happen. So we ignore lines 3 and 4. We jump immediately to line 5 and 6, which prints out the result. By contrast, though, let's do this one last time. Python of number.py, let's type in cat or, again, any other word and hit enter now. We don't see what x is. Rather, we see, quote unquote, x is not an integer, which is what's being handled in my except clause. All right, let me pause here, because that's a lot of new syntax, and see here if there's any questions on try, on except, on else, name error, or value error.
Can you please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes.
Yeah, so let's just rewind a couple of lines here before I fix this problem by now getting rid of the else. A moment ago, we had code that looked like this, whereby I was getting a name error, Python of number.py, enter, typing in cat, that looked like this, where name x is not defined, and the problem was on line 6, according to this output in Python. Well, let's think about this now deductively. Let's try a different approach. On line 6, I'm seeing an error that name x is not defined. OK, Python's already telling me x does not exist at that point. So how could that possibly be? Well, where should x be defined? Well, presumably x is defined on line 2 up here. So what could go wrong? Well, if the user has inputted something that doesn't look like a number, like the word cat, passing cat, the return value of input, as the argument to int to convert the word to an int makes no sense. You can't convert a cat, C-A-T, to an integer at all. So the int function is raising a value error at that point, and the error is being handled with this code here. But notice, this line 6 is not indented. It's left aligned with the rest of my code, which means no matter what, line 6 is going to execute. It's going to execute whether I typed in 50 or I typed in cat. But if I typed in cat, again, x never gets a value, so it's not defined here on line 6. So when I introduced finally the else statement, that makes sure that these things are mutually exclusive. I only execute the else if I tried and succeeded up above. Well, let me propose that we refine this just a little bit further as well and consider how we might improve this example a little bit more. It's a little unfriendly of me to be rejecting the user's input after they fail to provide an integer and just quitting the program really, right? It'd be more user-friendly if I just prompt or reprompt the user again and again. And in the chat, if you could, what's the feature of Python that you can use if you want to do something again and again and again until such time as the user cooperates and gives you what you're looking for, like a number? So yeah, loop, loop, loop. So a loop is something that happens again and again and again. And maybe we can use that same mechanism, a loop, in order to prompt the user for x. And if they don't give us a number, prompt them again. And if they don't, prompt them again and again and again. We don't need to just quit out of the program so quickly. So let me propose this. Let me propose here that I improve this code by deliberately doing this. Let me induce a infinite loop at the very top of my code with while true. Recall that the while keyword induces a loop, a cycle that behaves like this, and it asks a question, a Boolean expression that needs to evaluate either to true or false. Well, if I want this thing to loop forever, at least initially, we'll just say while true, because true is true, so this has the effect of doing something no matter what forever, unless we break out of it early. Now I'm going to go ahead and do this. I'm going to go ahead and move my try except code indented underneath this loop so that I'm trying to get an x. If I have a value error instead, I print out x is not an integer. But this time, what do I want to do if the user does try and succeed in giving me a number? Well, I can do this. I can just break out of my code here. And down here now, I can use that same line of code from before, an f string that says x is, and then in curly braces, x again. So what's going on here? I think this code now, because I've added the loop, is going to have the effect of trying at least once, maybe a second time, maybe a third time, maybe 500 times until the user finally gives me what I want, which is an integer. And once they do, once there's no value error happening, then I break out of the loop, and line 9 executes as I would hope. So let me go ahead and try executing this version. Python of number.py, enter. What's x? Let me go ahead and type in the easy thing first, 50. X is 50. What just happened in terms of the control flow of this program, the flow of my logic? Well, I first found myself on line 1 inside of a loop. Hopefully, I'll get out of this loop. What did I then do? On lines 2 and 3, I tried to get input from the user and convert it to an int. Well, I was a nice guy this time, and I typed in 50, which looks like and is a number. So the int function converted it just fine and stored it from right to left in x. Except value error, there is no value error, because if I typed in a number, there's nothing exceptional happening. This is a boring, good execution of my program. So what happens? I break out of the loop. So again, the else clause is associated with the try, not with the except. And once I'm out of the loop, of course, I'm just printing out what x is. Well, let's try the other scenario that might happen. Python of number.py, enter. What's x? Let's try cat or any other word. Enter. This is now a new feature. I'm being informed what I did wrong. X is not an integer, so I'm getting some useful user feedback. But notice again I'm prompted, what's x? Well, let me try typing in dog. X is not an integer. What's x? Let me try bird. Enter. X is not an integer. What's x? And suffice it to say, this will happen now forever if I'm in an infinite loop until I try and succeed, at which point I break out. So let's try again. 50, enter. Now I'm out of the loop, and I'm printing out what x actually is. All right, let me pause here and see if there are any questions. The logic is almost the same, but what is different now is I'm in a loop, and I'm using the keyword break in Python to deliberately break out of the loop when I'm ready to, once the user has cooperated.
Do we really need to break? Can't we just print? Or what keeps us from just printing?
Good question. So let me try that. Couldn't I just print? Well, let's see what happens if I do that. Let me move this print line at the end into my loop here, thereby shortening the program. And in general, that's been a good thing. Python of number.py, enter. Let me go ahead and type in 50. OK, x is 50. What's x? OK, maybe it's 49. X is 49. OK, maybe 48. Unfortunately, I think you're laughing. You see it. I never break out of the loop, which maybe that's a feature. Maybe you want this to be your program, but I didn't. I'd eventually like this game to stop. So I need to break out in that way. But I can do it a little differently. And let me propose that we modify this a little bit. But first, any other questions on this syntax here? Let me rewind to the prior version.
Hi, can I use break or in exception, except in else? For example, in another print, when you use print in the else, you can use print together with break or something like this?
So you can use break inside of loops to break out of loops. And you can use it inside of a conditional, like an if, an elif, or an else. You can do it inside of a try, except, else statement too. Anytime you're in a loop that you want to break out of, you can use this keyword break. I'm using it in the context of exceptions, but it's not restricted to that. And let me show you too, it doesn't even have to be in the else. If I wanted to, I could actually do this. I could get rid of my else, and I could go back to line 3, add another line that's indented, line 4, and break out here. Now, why is this logically OK? Well, consider what I'm now trying to do. I'm trying to execute line 3 and converting the user's input to an int. And I'm trying to store the result from right to left in x. If something goes wrong, the code we've already seen is immediately going to jump to line 5 and then 6 to handle the exception. But if nothing goes wrong, my code presumably should just keep on executing line by line. So I could technically, logically put the break here and watch what happens when I run this version. Python of number.py 50 enter. It worked. I broke out of the loop. Now, which way is better? Honestly, I think it could go either way at this point. This program's so relatively short that even though I'm trying to do two things now, one of which, the break, is not going to fail. Like you either break or you don't. There's no piece of data from the user that's going to influence that. We don't strictly need to have those 2 lines of code there, but it's only 2 lines, so I think it's OK. And if you recall our discussion in the past, not just of correctness, does the code work as it should, but design, I think you could argue it either way. If you prefer the readability of this and the fact that you don't have an else, that's fine. If, though, you prefer to minimize just how many lines of code you're trying to execute in case something goes wrong, the else is a reasonable approach too. Well, allow me to propose too now that we refine this further. I think we're at the point where it's pretty darn correct. But suppose now that I find myself today and tomorrow trying to get numbers from the user quite a bit. It would be nice, as we've seen, to maybe just invent my own function, getInt, to get an integer from the user both today and tomorrow and beyond. And heck, maybe I can even share that function with other people if they want to write programs that get integers from users. So how might I go about doing this? Well, let me go ahead and propose that we do this. Let me get rid of the print line, but keep most of my loop here. Let me define a function called getInt that takes no arguments for now. And I'm going to go ahead and indent all of the code I already wrote underneath getInt. So now I have a function called getInt that tries to do the following. Try to get an int from the user. If something goes wrong and there's a value error, yell at them with x is not an integer. Else, break. But it's not just breaking that I want to do here. Now that I'm in a function, recall our discussion of return values. If you're inventing your own function whose purpose in life isn't just to print something on the screen like a side effect, but is to hand back a value, to hand you back a value, like on that same post-it note from our discussion of functions, well, you need to return x explicitly. How do I now use this function? Well, as soon as we start making our own functions, it tends to be convenient to define our own main function as well. That's the main part of our program. And I'm going to keep this simple. I'm now going to say x equals getInt. And then on the next line, I'm going to do that print from before, quote unquote, x is, in curly braces, x. And at the very bottom of my program, recall, I'm going to call main so that no matter what, I'm invoking my main function after everything's been defined. Well, let's see how this works. Let me go ahead and run Python of number.py, enter. Let's type in 50, and it seems to work as before. Let's go ahead and run it again, typing in cat, C-A-T this time. X is not an integer, and I'm being prompted. Dog, and I'm being prompted. Bird, and I'm being prompted. Fine, 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 50. That's an int, and so it is printed. So what's worth noting here? Well, I'm manifesting a couple of good properties here. One, I've kind of abstracted away this notion of getting an integer. And even though I just artificially hit enter a whole bunch of times just to hide that function for now, it needs to be there, but we don't need to see it at this point. Notice that now this entire program really boils down to just these 3 lines of code now. Why? Because I've abstracted away that whole process of getting an int from the user into this new function of my own called getInt. But can I improve upon this? Well, let me go ahead and undo all of those blank lines and pull this up just so we can see more on the screen at once. Can I tighten up my implementation of getInt? It is correct. I claim this is correct. It's handling errors and it's returning x. But I don't, strictly speaking, need to write the code as long. What else could I do? Well, let me propose that if all you're doing on this line 13 is breaking, and then immediately after that, per the indentation, you're executing return x on line 14, why are you wasting everyone's time? Once you know you're ready to return the value, you could just return x. And so in my else, I could break out and return a value. So here too, return is used to return values from functions. Break is used to break out of loops. But it turns out that return is sort of stronger than break. It will not only break you out of a loop, it will also return a value for you. So it's doing two things for once, if you will. But can I make this even more compact? If my goal is to just tighten the code up, even though it's already correct, can anyone think of a further refinement, whether you've programmed in Python before or not? Can I shorten this implementation further, just a little bit, if only to decrease the probability that I've made a mistake by having fewer lines, and just make it a little easier to read because it's shorter? Any suggestions for tightening up my implementation of getInt?
You can just return the value on the try function when you're trying. You take the input x and then return x.
Good. We can just return x a little higher up. And let me correct folks as we go. It's not a try function. It would be a try statement, technically. A function typically has a parenthesis and another one. In this case, it's just a statement. But we can do exactly that. I don't technically need the else. If I really want, I could do this. Right after line 9, I could return x here. Or recall our discussion of defining variables unnecessarily sometimes. Like, why define a variable here if you're immediately going to use it here and then never again? So we could avoid a new line here. And I could avoid even defining x explicitly. I could just say something like this. I could return int input, quote unquote, what's x. I can do it all at once. Now, which is better? I don't know. I mean, again, this is where reasonable people might disagree. I'd argue that on the one hand, we're tightening up the code. We're using fewer lines. It's easier to read, lower probability that I've made a mistake. On the other hand, it's a little more complicated to understand, perhaps. It's a little less obvious where I'm returning from. So I think arguments can be made either way. At the end of the day, what's important is that you've done this consciously. You've made a decision to do it this way or this way, and you can justify it in your mind, not that your answer is, it worked, so I left it alone. Like, have a good reason. Come up with a good reason, and that will come with experience and practice. Well, let me propose, too, that we make one other refinement here. Suppose that you're finding your programs to be a little noisy, and it's a little obnoxious that you keep telling the user x is not an integer, x is not an integer, x is not an integer. What if you want to make things a little gentler and just prompt the user again with the same words, what's x, what is x, what's x, again and again? Well, you can do that as well. And it turns out that if you want to handle an exception in Python, but you want to pass on doing anything with it, so you want to catch it, but you essentially want to ignore it. You don't want to print anything. You don't want to quit the program. You just want to silently ignore it, like if you're talking in a room full of people and it's your turn to talk and you're just like, pass. They're still calling on you, but you're not doing or saying anything more. Well, we can add this keyword to our code here. Let me go back to my program here. And instead of printing out again and again, x is not an integer, I could just do this. I could pass on handling the error further. I'm still catching it. So the user is not going to see a scary message even mentioning value error. My code is catching it, but I'm passing on saying anything about it. I'm going to stay in the loop. I'm going to stay in the loop and keep prompting and reprompting the user. So now the effect looks a little something like this. Python of number.py. Let's type in cat. What's x again? Let's type in dog. What's x again? Type in bird. So it's just a little maybe more user-friendly in that you're just reminding the user what you want. Maybe it's worse. Maybe it would be helpful to tell the user why you're prompting them again and again. It's not obvious, so it could go both ways. But again, it's just another mechanism now for handling these errors. We use the except keyword to catch a specific error, but we don't have to handle it more than that. We can just pass on doing something further. Let me pause here and see if there's any questions now on try, accept, else, or pass?
Okay, yeah, no, I was just kind of curious, I guess, about the idea of when you were indenting with the getInt function, for example. Because I'm noticing, obviously going through it with the whole logic and breakdown of the entire function, while true, do this. But I'm just kind of curious on elaborating with the indentations for the code more.
Yeah, so the indentation is deliberate logically. Some languages don't require as rigorous indentation. You can use curly braces or other symbology to make clear what is associated with what. In general, anytime you indent something in Python, on this line. So rather, anytime you write a line of code in Python that's here, and the lines below it are somehow indented, that means that those lines are somehow associated with that first line. And presumably, those indented lines should only be executed if the first line told the computer to do so. So concretely, what does this mean? On line 6 here, we're defining a function called getInt that takes no arguments, colon. Everything that's indented by at least 4 spaces hereafter is part of that function. Why? That's just the design of the Python language. Frankly, I think the designers got tired of seeing really ugly code in languages like C and C++ and Java that don't necessarily enforce indentation to this extent. So now it's baked into the language. And my chronology might be a little off there, but there's been many languages that are looser than Python when it comes to indentation. The indentation is meaningful on line 7 too. Notice that because the while true is indented by 4 spaces, that just means it's part of the getInt function. But notice below the while true statement, there's 8, there's 12, there's 8, there's 12 spaces here. And I'm just quickly counting the dots. That means that all of the lines I've just highlighted are inside of that while loop. While true means to execute lines 8 through 11 potentially again and again and again. And now lastly, on line 8, because we have try and indented below it is line 9, that just means that what you should try is what's on line 9. And similarly, on line 10, below it, we have indented line 11. You should only pass when there is an exception of a value error. So the indentation just means what is associated with what. And once you get comfortable with that, you'll see that it helps, the indentation alone helps explain the logic of your program. And it has a wonderful side effect that for yourself the next morning, for your colleagues, your family, your friends, your teachers, your code is much more readable as a result. It's not one big mess of a blob of text. Other questions now on try, except, else, or pass.
Yeah, thanks. Two questions. Question one, once you say pass, can the caller still learn anything about this error through a system variable or whatever? And question two, problem set 0 referenced some string methods, including is numeric. Is it any different to go via is numeric here?
A good question. So on the first question, if I'm handling the error in this way, the caller is not going to know anything about it. That's the point of my handling it, so that main or other callers don't know that anything technically went wrong. On the second question, is numeric is another function that you can call that can look at a string and determine, is this in fact a number? I could use a mechanism like that. I could use a conditional. If this looks like a number, then pass it to the int function and go ahead and convert it to an integer. That's totally fine. I would generally say that the Pythonic way of doing things is often, for better or for worse, to try things, hope they work, but if they don't, handle the exception. So other languages are more in favor of checking if, elif, else, and all of these conditionals. Python tends to be a little more of the mindset, try it, but just make sure you're handling the error. So this would be the Pythonic way of doing it. Your way, though, checking with a conditional, is it a number first, is totally reasonable too, if you want to go that way. Well, let me propose some final refinements to this program that really just kind of tighten things up one additional step to improve the implementation of this getInt function. Let me propose that we not hard code, so to speak, that is, type manually x all over the place. Let's make this function getInt a little more reusable. Right now, notice that I'm just kind of using the honor system that, well, main is defining a variable called x, and getInt is asking for a variable called x. But it would be nice if the caller, main, doesn't have to know what the callee is naming its variables, and vice versa. So caller, to call a function means to use it. The caller is the function that's using it. The callee is just the function being called. It would be nice if I'm not just hoping that x is the same in both places. So let me propose this. Let me propose that we actually add a parameter to getInt like this. What's x? That is to say, if main wants to use the getInt function, well, then main should probably tell the getInt function what prompt to show the user. Just like the input function, recall, that comes with Python, it's up to you to pass in a prompt that the user then sees when the human is asked for input. So how do I make this work here? I can go down to my definition of getInt, and I can say, all right, getInt is going to take a parameter now called prompt. I could call it anything I want, but prompt in English is pretty self-explanatory. It means what do you want, the message the user will see. And now down here, when I actually use input, I don't have to presumptuously say what's x, because what if the program, the caller, wants to ask for y or z or some other variable? I can just pass to input whatever prompt the caller has provided. So now I'm making more reusable code. It still works just the same. I haven't changed the functionality per se, but now it's a little more dynamic, because now getInt doesn't have to know or care what variable is being asked for, what's being asked for. It just needs to know what prompt it should show to the user. So if I now run this program down here again, prompt number.py, enter, what's x? 50. Still seems to work. Let's run it again. Let's type in cat. It still seems to work. And if I type in cat, dog, bird, or anything else, it will keep prompting me with that same prompt, making this code, therefore, all the more usable. Now, it turns out, too, you can even raise exceptions yourself using Python's raise keyword, but more on that another time. So in the coming days, the coming weeks, the coming months, as you write more code in Python, you'll see that errors are inevitable. Sometimes there's syntax errors, which you got to just fix if you even want to run your program at all. But they could be name errors, for instance, variables that you meant to define but somehow didn't. Value errors, where maybe the user didn't cooperate and provided you with something that you weren't expecting, or a whole list of other possible errors or exceptions. But now, hopefully, you know how you can handle these errors and respond to them in any way you like. This, then, was our look at exceptions, and we'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is a look at debugging. Odds are by now you've written quite a bit of code, and within that code is at least one, maybe even more bugs. That is, mistakes that you accidentally introduced to your code. Now, maybe your code doesn't even run at all, and you have some form of syntax error. Or maybe you've gotten past that hurdle, and you just have one or more logical bugs, so to speak, whereby when you run your code, it doesn't produce the output that you actually intended. So it's not quite correct. There are mistakes therein. And how do you go about then solving those problems? Well, if you can't quite wrap your mind around what's going wrong by just reading with your own human eyes your own code from top to bottom, left to right, and you don't have, for instance, a teacher, a friend, a colleague, a rubber duck to help you reason through what might be wrong in your code, what kind of tools do we actually have for chasing down bugs in code and ultimately fixing them? Well, already we actually have some tools at our disposal. And for instance, let me propose that we build something like this in code. So pictured here is Mario from Super Mario Brothers, the original Nintendo game, jumping over a pyramid of sorts. And that pyramid is implemented with these bricks of sorts. Let's go ahead and create a textual version thereof, whereby we use maybe hash symbols, simple hashes, to represent each of these bricks. And therefore, the goal in printing out a pyramid textually that resembles that of Mario here would be to print out one hash, and then two hashes, and then three hashes, and perhaps more if the pyramid itself is higher. Well, let me propose that if I open up VS Code here, and in advance I've created a file called mario.py, let me propose that this is my intended solution to this problem. Let's go ahead and walk through what's here. I first, at the top of my file, have a main function defined, inside of which is a second line of code that calls input, asking the user for the height of this pyramid. Immediately, the return value of input is passed to the input of int, so as to convert that textual input, presumably, to the corresponding integer. And then I'm storing on the left-hand side of that equal sign the value that the user typed in, be it 1, 2, 3, or anything else. And then I'm using that variable as an input to a function that's apparently called pyramid, so that I can ultimately print out a pyramid of that height. All right, well, what is this pyramid function? Well, it looks like on this line 6 that the pyramid function expects one argument called n presumably for number. And how am I using that number? Well, inside of this function, I have a for loop that's going to iterate, it would seem, n times. And this is indeed our common paradigm. Doing for I in the range of n allows us to iterate from 0 on up. And then that innermost line of code is just going to go ahead and print out some number of hashes. And recall this trick whereby we're using the multiplication operator, but really just to automatically concatenate one or more of these hashes together. So hopefully the net effect of this program, once we actually run it per these final two lines, and main is invoked and then pyramid is invoked, is that we'll get a pyramid of the corresponding height. But suppose now that I very enthusiastically went about trying to run this program, and so I went to my terminal window and ran Python of mario.py, and then I went ahead and proposed a height of 3, the goal being to have 1 hash, 2 hashes, 3 hashes, so that the total pyramid is of height 3. I'm a little disappointed already to see that it's not quite correct, this output. I seem to have a pyramid really of height 2 because there's a blank line and then a single hash and then 2 hashes. But again, what I wanted was 1 hash, then 2 hashes, then 3 hashes, forming a pyramid that's in total of height 3. Now, you might have an immediate instinct as to how to fix this problem. And indeed, relatively speaking, this isn't the most complicated program, at least if you're a few weeks into learning and writing code in Python. But suppose that it's just not obvious to me, or this is representative of an even more complicated problem down the road. And so I'd really like to start figuring out systematically how to solve this particular bug. Well, what's one tool in my toolkit? Well, let me propose first that I do this. Let me clear my terminal window to get rid of the output from before. And let me propose that it might be helpful for me to maybe figure out if maybe I is wrong, right? I is my variable in this for loop that's responsible for printing out, presumably, 1 hash, then 2 hashes, then 3 hashes, and so forth. So maybe just to check my understanding here, I should, maybe why don't I temporarily just print out I in addition to these hashes, just so that I can make sure that I is what I expect next to the appropriate number of hashes, which is to say print itself, the function we've been using now for quite some time, is a very reasonable, effective tool for debugging, at least in some cases. It's a nice way to quickly and dirtily kind of see what's going on inside of your code. Well, let me do this. In addition to printing out that number of hashes, let me also print out the value of I. But rather than print out a new line, which I think is going to completely mess up the pyramid, let me just end the line with a single space, just to kind of push the cursor over to the right so that my pyramid is printed to the right of all of these integers. All right, let me go down to my terminal window again and run Python of mario.py, enter. I'm going to again type in 3 for the height. And now I see essentially the same output, but I've prepended, so to speak, to each line the value of I. And now maybe it makes a little more sense to me. Now maybe the proverbial light bulb just went off over my head because, oh, the reason I'm seeing a blank line and then only 1 and only 2 hashes on the screen instead of 1, 2, and 3 respectively is because I, of course, now I remember, starts from 0, certainly when doing a for loop like the one I have here on line 7. So how do I go about fixing this? Well, I think instinctively I could just do this. Let me go ahead and remove the previous print. Indeed, when using print to debug your code, it's usually temporary. So I should now undo that change because I don't want those numbers to appear ultimately in my program's output. Let me go ahead now and print out, OK, I don't want to print out 0 hashes and then 1 and then 2. I want to print out 1 more than the current value of I. And I bet there's a bunch of ways I can solve this, but I think the easiest way might be this. Let me go ahead and in parentheses do I plus 1, so that what I'm really doing is multiplying this single hash by I plus 1. So instead of being 0, 1, and 2 hashes respectively, now it's 1, 2, and 3. And I've parenthesized it just to make clear to myself that indeed the math is going to happen first, just like in math class, inside of the parentheses, and then I'm going to use that total value for the concatenation of all of those hashes. All right, let me go ahead now back to my terminal window, clearing it, running Python of mario.py once more. Let's again type in a height of 3, and now I have the intended pyramid. So a minor bug, if you will, certainly if you're several weeks into learning Python already, that kind of bug might have jumped out at you pretty quickly, but that's not always going to be the case. And so print is the first of your friends when it comes to debugging your code. Using print, you can temporarily, but pretty easily, just display the values of variables or other things in your program, just so you can help see what the computer sees underneath the hood, so to speak. But it turns out there's more powerful tools, and print can start to get a little tedious, especially if you're adding a print up here and up here and up here and up here and all over the place in more complicated programs, because then you have to clean up a whole mess that you've made, and you might have put the print in not the right location, and you have to remember what output is coming from one print. So eventually, print is not so much your friend, and we need better tools than that. So let me go ahead and clear my terminal window again. Let me undo these changes so that I again have the same bug where I'm now printing out I number of hashes, so 0, 1, and 2 again. And let me propose that we use another tool that comes with a lot of programming environments nowadays, VS Code included. Indeed, typically I've hidden the so-called activity bar to the left-hand side here of VS Code, but I've revealed it today so that we can see some of the functionality that actually comes with VS Code. And other text editors and other IDEs, integrated development environments, often come with built-in debuggers. And indeed, a debugger is a special type of program whose purpose in life is to do just that, to help you debug your program. It doesn't necessarily solve the problems for you, so it's perhaps a bit of a misnomer, but it helps you. It empowers you to solve bugs yourself and eliminate them more methodically than maybe print alone would allow. So I'm going to do this first. I'm going to introduce this notion of what's called generally a breakpoint. A breakpoint is simply a mechanism when using a text editor or an IDE that allows you to specify on what line or what lines of code do you want to pause or break execution of the program just so you can start poking around at that line of code. In other words, if I keep running mario.py in my terminal window, it pretty much runs from top to bottom, left to right, again and again, pausing, of course, for my own human input. But it's so darn fast, Python, that I can't really see what's happening on each individual line of code. So let me go back to VS Code and this time set a breakpoint. Wouldn't it be nice if I could pump the brakes, so to speak, and slow down the execution of my program so that I can tell the computer when I, the human, am ready to step through each of my lines of code. So it turns out that to the left of the line numbers here in VS Code, and this is a popular approach in other programs as well, notice if you hover over to the left of a line number, it becomes a grayed out form of red. And if you click on it once, it becomes really red. And what that indicates is that I've set one of these things called a breakpoint. I've indicated to VS Code in this case that I want it to break, that is, pause execution of my code just before main is called. And I can actually set it on almost any of these lines of code, but I'm starting at the very bottom one because, of course, that's the line of code that we know is going to kick off the whole process of running my code, but it's going to allow me, therefore, to step through any and all of the specific lines therein. So let's go ahead and do this. But now I'm not going to go ahead and just run Python of mario.py. I need to actually run the debugger. And the debugger in VS Code is pretty smart to figure out exactly what I want to run. And you can even configure it to be even more customized. I'm going to go ahead and perhaps aptly click on this icon here, aka run and debug. And it's the little play icon with what appears to be an actual bug on it. And when I click that, this additional panel opens up in VS Code. And its big button there is called Run and Debug. Now, I could follow more of the directions and customize it further, but I'm just going to go ahead and click Run and Debug. And using some default settings that I might have specified earlier too, it's going to run my program, but pause it on this line here. Notice that in yellow on line 12, that's where I set the breakpoint, and the yellow highlight of line 12 means that line of code has not yet executed, but it's about to be executed if and when I am ready. There's a bit of noise or messy output in my terminal window potentially, but that's just part of the debugging process. In my terminal window, eventually will I see that same prompt for height. But I don't yet because I'm not at that line of code. Now, let me draw your attention to all of these icons at the top of the screen. The first of these, which looks like a play button with a line to the left of it, is this continue button. If I click that button, the breakpoint is going to be left behind, and my code's just going to continue on to the end of the program. That's probably not what I want in this case, because I actually do want to step through it line by line. There's this next icon here, an arrow going over a single dot. That's the step over command. This would allow me to step over this line 12. It will execute it, but that's it. It's not going to step into that function so that I can go line by line through main or in turn pyramid either. The one I really want to use now is this one in the middle, step into. And this is the line pointing down at the dot, which is a symbol that indicates that if I click this button in a moment, I'm going to step into line 12. That is, I'm going to step inside of the main function. And from there, I can continue to step by step, walk through my code. So watch what happens on the yellow on the screen here when I click step into like this. You'll see that now line 12 has begun executing, but when we step into that function, notice now that the debugger has broken or paused on line 2. Line 2 has not yet executed, but as soon as I step over this one, I think we're going to start to see some results. And I was careful there to say step over instead of step into. Why? Well, notice on this line of code 2, there's two functions, input and int, and I didn't implement either of those. And allow me to propose that the people who invented Python probably implemented input and int correctly, so there's really no point in my stepping into their functions or even trying to. I really should only be stepping into my own functions. But I do want line 2 to execute, but let me call your attention to this. At the top left of VS Code now, there is under the Run and Debug panel some mention of variables, both locals and globals. And there's nothing under locals at the moment, because at this moment, before line 2 has been executed, no variables actually yet exist. In a moment, once I do execute this line of code and step over it, well, a variable called height should exist. So let's try that. I'm not going to click step into. I'm going to click step over. But that will not ignore the line of code. It will execute it, but not dive into it, if you will. Once I click step over, notice that the line is no longer highlighted because execution hasn't broken or paused yet. Notice in my terminal window, despite the output from earlier, I'm being prompted for the actual height of the pyramid. So this part is still interactive. Let me go ahead and type 3 and hit enter. And now we'll see what's happened at the top of the screen. Line 2 has just executed. The height variable now exists. And indeed, if you look up here, you'll see in the debugger a graphical summary of all, or in this case, the one variable that now exists. And better still, you see the value of that variable. Now, that's not that helpful at the moment because I'm pretty sure the height is as the user typed in. So there's no off by 1 error or any bug there. I think then the bug is probably inside of my pyramid function. So here, I don't want to click step over because that's going to execute pyramid and not allow me a chance to step through each of its lines. I'm going to, again this time, because it's my function, step into the pyramid function. Once I do that, now it's line 7 that's highlighted because I've stepped into the pyramid function. Notice that the panel up here is changed. The local variable, that is the variables that exist local to the pyramid function, are indeed n, because n was the argument that was passed in with a value of 3. I does not yet exist because line 7 has not yet executed, but here comes my for loop. And here's where it's going to be interesting to step over and step over a few times. I don't want to step into because the range function, again, was invented by someone other than me, and let's just trust that it's correct. So let's step over this line, thereby executing it, but watch the top left-hand corner of VS Code. Let's step over it once. And now notice, not only does n equal 3, now there's another local variable called I that equals 0. And what am I about to do on line 8? Well, in a moment, I'm going to click step over again, because I'm going to trust that print is correct, so I don't need to step into print. But watch what happens now in my terminal window down here. No pyramid, no bricks have been printed, but as soon as I step over line 8, thereby executing it, we see the first of my, wait a minute, I'm not seeing an actual brick. If you notice, the cursor did move down, and effectively a blank line was printed, and now there's an opportunity for that light bulb again to go off. Wait a minute, I saw the cursor move. It printed something, but it's really nothing. It's no bricks. Oh, this is where now I might realize this is why my program is flawed, because when I equals 0, I'm apparently printing 0 bricks. Aha! Now, hopefully, I understand. If not, no big deal. I can continue stepping over or stepping into each of my lines of code. I can click the big stop icon, or I can restart the whole process. Sometimes it might not be obvious the first time around, and sometimes you might want to unset or reset a different breakpoint so as to figure out what's actually going on. It's just part of the process of debugging. For now that I figured it out, I'm going to go ahead and just continue my program because I know that it's flawed, but I now know what the problem is. Let me go ahead and close this panel over here. I'm going to get rid of the breakpoint because I've now, in my mind at least, solved this problem. I'm going to clear my terminal window. I'm going to go in and just logically add what I think is the solution to this problem by doing I plus 1 in parentheses again. I'm going to now run one final time Mario.py with Python. I'm going to again type in height of 3, and there it is, my pyramid of height 3. So ultimately, what are the tools in your toolkit? Well, certainly print is something that you can always reach for, not just in Python, but so many other languages as well, or some equivalent thereof. But sometimes once your programs get sufficiently complicated, sufficiently sophisticated, or heck, maybe it's someone else's code that you yourself didn't write, and therefore you would especially benefit from stepping through it line by line, stepping into functions of interest. A debugger like that comes with VS Code is going to be your new best friend.